Let's hop on stage today.
So now you're here again, knocking at my door. A little too late for, I'm sorry for. The lights went out cause you kept cutting the cord, and I started to fade into your gray. See, I finally opened up my eyes, and I saw me coming back to life. That I'd be better without you inside. It's time to be someone I wanna recognize. The future starts right now. I made a reservation, but you never came, so I'm checking out. The fire you stole away, I know one day we'll come back around. The future is now. I waited for you in the passenger seat. There's only so far I can ride in your dreams. While you were chasing everything else but me, I'm starting to break out from your gray. See, I finally opened up my eyes, and I saw me coming back to life. That I'd be better without you inside. It's time to be someone I wanna recognize. The future starts right now. I made a reservation, but you never came, so I'm checking out. The fire you stole away, I know one day we'll come back around. The future is now. The future is now. I'm not backing down, cause the future is now. Not backing down, cause the future is now. The future starts right now. I made a reservation, but you never came, so I'm checking out. The fire you stole away, I know one day we'll come back around. The future is now. The future
from the mud. There's dirt on my hands. Strong like a tree. There's roots where I stand. Oh, I've been running from the law. Hope they won't shoot me down soon. They sing on a sleepless night. Try to catch me howling at the moon. 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 When it rains, it pours. Water's up to my chin. Won't stop fighting to the very end. Many men tried to reach it. Many men have failed. Well, if you wanna get to heaven, you gotta raise a little hell. And I've been running from the law. Hope they won't shoot me down soon. They say no to sleepless night. Will you find me? Hope you find me. I'll be back home soon. When the sun rises, when the sun We're trying to catch me high.
Hello, everybody. A warm welcome from my side on the Grace Hopper stage at the second day of the Big Data AI Summit 2022. My name is Lukas Klingholz. I'm responsible for cloud and AI at Bitkom, and I'm your moderator for the next 3.5 hours. And I'm very happy to directly introduce the first speaker on the Grace Hopper stage today, which is Krupakar Singampally. He is practice lead for advanced analytics at Infosys, and he's talking about AI-based forecasting for B2B manufacturers using Amazon Forecast. The stage is yours.
Thank you. I'll just start sharing my screen here. I hope you're able to see the screen.
Yes, we can see the screen. Perfect.
Great. Good morning, everyone. I'll be speaking to you about a recent program that we executed for a manufacturer in the US. Let me jump directly to the context of the case. Yes, minimize the screen here. Yeah. So this is a global HVAC company, that is an air conditioning chiller manufacturing company. It's a leading company across the entire world. And they were looking to execute a AI-led supply chain transformation, starting with demand forecasting. The intention was, as we improve the forecasting that we do, the accuracy of forecasting, it gives us greater opportunities for inventory optimization, reducing lost sales, and further optimization down at the factory level in terms of resource planning, etc. This particular stage of the program required us to build a fully automated, at scale AI-based solution for demand forecasting across 34 different product groups and hundreds of stock keeping units. Let me give you a few more details about the business problem and the value proposition. If you see the top part here, let me just grab my pointer. If you see the before we did the program, the way demand forecasting was being executed across a variety of very distinctive brands, none of which have, they all have very different kind of drivers, was manual. The forecasting was being done by a couple of demand planners in Excel sheets. It was qualitative, judgment driven. They were using industry parameters and various kinds of indices, but it was all up to their judgment on how they use that information. And it was primarily driven by the historical sales trends. As a result, the plan that emerged was inaccurate, the forecast was inaccurate to the extent of about 35% of average error across all of these brands and SKUs. And that resulted in the manufacturing centers, there would be a lot of waste because you are over ordering or under ordering your raw materials. And there were also these kind of outcomes that you see here. Many of these products were also made to order, and because the raw material procurement was driven by this demand plan, the cycles of time to fulfill a made to order was in the order of months. So if a customer places an order, it takes several months for that product to be delivered to that customer. From there, we have moved to this forecasting, where we are not only using historical sales as quantitative data, but also demand drivers beyond just the trend and seasonality that is evident in the historical sales. And we were looking at external factors which were being considered here, but qualitatively. Now we were taking them as quantitative inputs into an AI model, which the details of which I'll speak to in subsequent pages. And as a result, we improved the accuracy of the forecasting to 25%, 20% from a 35% average. I also should mention this 35% average was at a category level, whereas we achieved 20% average at the SKU level, a level lower, which is always more advantageous. And then if you see the breakup in terms of made to stock versus made to order, the forecast improvement that we did was in the order of 44% and 11%. And the outcomes that we expect are these: that we get more predictability, and ultimately the business value that the client is looking for is in these kind of factors. Now let me go a little bit more into the detail. Before I go into the modeling approach, I just wanted to mention a few challenges that we had to, interesting challenges that we had to deal with. As I mentioned earlier, there were a good mix of made-to-order products. Made-to-order is inherently harder to forecast because they are tailor-made to customers and their demand is lumpy and intermittent. That presented a challenge for us. There's also this all this forecasting that we were doing were in the context of B2B sales, that is industrial customers. This is not retail. So aspects such as promotions, competitor activity, etc., are much harder to gauge and account for. And the demand profiles of these products were very different from each other. Some were very frequent, some were erratic, lumpy. That is, the demand would occur in big lumps, and then there would be long gaps, and intermittent. And we also had to account for COVID effects because we just completed this program and it was being executed during the COVID effect pandemic, which means that the demand was behaving quite erratically. If you see the actual sales pattern across the entire year of 2020, it was very erratic. What was our solution approach? If you see, the inputs that we considered were the historical sales data. So this sales data was being provided to us at an SKU level, and we had the last 3 years of data that we were considering into the model. And then we considered a variety of external indices for informing the model. The AHRI is the industry level index that tells you at an industry level for the air conditioning industry how many products are being sold month on month. Dodge tells you what is the construction awards that have happened in this month, which is the new buildings that are going up, which has a correlation with the kind of industrial air conditioning and chillers that has to go into production. HSPU gives you the non-commercial construction right now that is already existent. Wholesale price index, the industrial index of production, GDP. I assume that they are obvious. And we also considered things like percentage of cold areas and warm areas, but they turned out to be not so relevant because this is really industrial ACs, which are not driven by, whether the need for climate control is not based on a local weather pattern. The most correlated factors that we saw were these, the AHR and Dodge, but all of these factors ultimately went into the model. And the model itself, if you look at the models that we used, we looked at Amazon Forecast. Amazon Forecast is a service provided by Amazon that provides these models out of the box. Some of them are neural networks, some of them are time series. I have a slide that explains this better. But what Amazon provides you is this suite of models against which you can train this data and get predictions. And we use these as features. For instance, price category, like a premium product versus a basic product would be evident from the price category. The marketing category represents the broad nature of use of these products, whether it is chiller or whether it is a gas-based chiller, etc. External indices that I already mentioned. Demand profile, as you can see here, would be determining whether it's a smooth, erratic, etc. And that has a big bearing on the prediction model that would be selected. And for each of these products, which is the dominant customer industry and the secondary customer industry that would consume these products, that is another factor that we considered. So it could be education, it could be hospitals, it could be malls, etc. All of these would enter into the consideration. And we, on top of the forecasting model that Amazon provides, we did this feature selection. This was something that we had to do discretionarily, as well as this champion selection that the Amazon forecast doesn't provide. What it means is that at any point of time, we are training all 6 models on all the history of data and selecting the best one of these based on a validation period for an individual SKU. That means for each individual SKU, a different model would be used based on the demand profile of that product. The most suitable one would be used, and that allows us to get the best out of these models. We also did a lot of hyperparameter tuning for these models, and the output was an SKU level forecast. A little bit of an introduction to Amazon forecast. Deep AR Plus and CNN QR are two neural network based models. They're very useful because they learn from a group of SKUs. Normally, any kind of machine learning model is based on individual SKUs time series, whereas here it looks for patterns among the group of SKUs and learn for each SKU, and hence it can support new product introduction scenarios, because if you introduce a new SKU, you can still forecast for it because it's going to learn from the patterns of the group. And it has powerful inbuilt lag and seasonality features such as the one that you see here. So depending on the frequency of your time series, for instance in our case we were doing it at a weekly level, it would generate derived features internally, lag features that allow you to forecast better. They are auto tuning, and they also support related time series data such as the indices, and various other kind of categorical inputs like the ones I was mentioning in this, can be used to group these SKUs further and learn from that. Apart from that, there are machine learning models and time series models as well. I'll not go into the details of it. Now, once we did the forecasting, what I told you about is the core forecasting approach there, but it was much beyond forecasting. What we needed was an end-to-end automated ML pipeline. So that is where we looked at creating this multi-stage model. The main intention of this multi-stage ML pipeline was on provenance tracking, so that at any point of time, when we do a forecast, we are very clear on what is the kind of transformations of the historical data that were performed to arrive at this forecast, in case we need to reverse engineer that and explain why a certain forecast is behaving this way. Reuse, because we want to make sure that whatever pipeline that we built can be easily scaled to other business units, other geographies. We made this pipeline as clean and modular as possible, and maintainability. As you can see, what we did was a stage two enterprise transformation, where there was a data processing pipeline that would look at data cleansing and converting the raw data to the enterprise data format and merging the external data with the sales data. As a result, what you get is the enterprise level formatted data, which we then convert into an analytical layer, which is ready for processing by Amazon Forecast. So this is where it's available in exactly the same way that Amazon Forecast would want it. So after we have this, we would subject it to the forecast pipeline, where we do a train test split, we would do a champion selection, we'll generate a rolling forecast, and then we persist that forecast. And we allow the user to interact with these forecasts through a workbench and a workflow. And we also have a MAPE calculation, or a performance calculation module, that allows us to continuously monitor how our forecasts are doing. So this end-to-end pipeline was also implemented as part of this transformation exercise. And was all done on AWS, as I'm showing you here that the raw data lake, which I explained in the previous slide, was in S3. The enterprise data lake was in Snowflake, and the analytical data lake, which is getting ready to provide the data to Amazon Forecast, was again in S3. And the Amazon Forecast service itself is an API call. And then we store the results again back in this enterprise data lake so that it can be used for further analysis. We do a performance assessment based on how these forecast results are versus the sales data that is coming in from SAP. And we show all of that in an AngularJS application that allows the user to update and view these forecasts. So that, that was a quick overview of what we did there. What I will do is, instead of talking further on the content here, I would open up the session for questions.
Until here. And we have a few questions in the chat. I'll start with the first question I see in the chat. Is from Sofia Trojanowska. And she asks, I'm just reading it to you, Dear Mr. Krupaka, what is the most important product that Infosys is providing in Germany and Europe, and how do you see the development of the IT demand of German manufacturers and chemical companies?
So Infosys provides a variety of analytical products. I assume, Sophia, that you're talking about products that are relevant to the kind of forecasting that I'm talking about here, or for AI services. So we have a variety of accelerators such as the Champion Logic that I was talking about in the previous slide. a variety of computer vision related solutions that manufacturers can use for doing defect identification and other kind of use cases in the factory floor. And we also have a couple of platforms that allow you to do data science at scale using standards. We call it the analytical workbench. So using that analytical workbench, you are able to execute data science in all aspects of the data science lifecycle in one platform.
Thanks a lot. We have two more questions I will just address to you. The next question is regarding the database you use for your sales prediction to train your models. And the concrete question is, do you have examples or do you have insights in how much sales data is needed, like to develop models which have a good prediction level?
Yeah, in this case, I think there were two questions. One was about the database and then the kind of data series that you need. The databases I'm already showing on screen here. In this particular implementation, we used a combination of S3 buckets and Snowflake as the databases. The reason for these choices, S3 was because it is the default data lake of AWS and it is cheap, easily scalable, and the perfect solution. Snowflake because that was their the client's enterprise standard for an enterprise data warehouse, and they wanted all of these key measures that were generating out of this forecast to be stored in that enterprise data warehouse. So that is the answer to your database related question. The other question was how much data do you need to make an accurate forecast? I think in this case we use 3 years of data. That's ideal because anything beyond 3 years is not very useful. The sales trends change too much over the period of time. Anything less than 3 years is manageable. We have done forecasting for other clients even with 1 year of data, but 2 to 3 years is ideal for us to capture seasonality patterns.
Perfect. So I will just follow up one question from my side, and then I will ask the last question. So are you agnostic if the customer wants to use another storage approach or another data lake approach, or are you aligned always to Amazon S3 and Snowflake?
No, absolutely not. I mean, we have executed similar solutions on other clouds as well. For instance, for another client, we have executed a very similar solution. In that context, it was returns forecasting rather than demand forecasting, and that was done on GCP and the whole choices that GCP provides, such as BigQuery and Cloud SQL, and we have similar implementations on Azure as well. So it really all the cloud providers provide you wonderful options in terms of storage and powerful forecasting solutions as well. We mix and match what is necessary for the context of the client based on their requirements.
Perfect. So I have two other questions which I will combine in one question, addressing it to you. The first question is regarding team setup. How many people do you need for such a development of a specific prediction model, and which roles do you see in such a project? And this combined with the question regarding time you need for fine-tuning the parameters of the model and select the best model.
Okay, so team structure wise, we had a program manager because this program required extensive coordination with the business users, with the IT infrastructure providers of the customer and their data science team. So program management was a key element. And then we had a core team of data scientists, which is about, I think, 3 to 4 people, one senior data scientist and 3 data science analysts. And we also had a team that was able to develop the AngularJS application, the workflow. It was a complex workflow. That was about 3 people for doing the front-end web development, and maybe and 1 or 2 other people who were taking care of the data engineering aspects of the end-to-end flow. So overall, about 10 people was what went into this kind of program. I'm sorry, I missed a second part of the question. Could you repeat?
No problem. Just maybe a few considerations regarding time you needed for fine-tuning parameters of the model.
Okay, that's a good question. I think the core models we developed using Amazon Forecast within 2 months from the start of the program. I think we spent about the next 3 months really in terms of fine tuning, because we wanted to first of all make sure that Amazon Forecast is indeed the best choice. So we created other models such as XGBoost, Random Forest, which are not available in Amazon Forecast, just to check that we indeed have the winner in Amazon Forecast. And then we spent a lot of time identifying the kind of features that I talked about here, all of these features in fine tuning these models. So I would say 2 months for the base model and another 2 to 3 months for fine tuning.
Thanks a lot, Mr. Singampally, for your insights, and thanks a lot for the discussion. I wish you a nice Big Data AI Summit and wish you all the best.
Thank you very much. Thank you for your time. I enjoyed it very much. Have a good day.
Goodbye. See you.
Bye.
So we are directly jumping to the next session, which is presented by Thomas Hahn. Thomas Hahn is Chief Expert for Software at Siemens, and he's talking about a team of rivals, business AI as a collaborative endeavor. So, Mr. Hahn, the stage is yours.
Hopefully you can understand me. Everything is fine. You can see my slides. Perfect. Many thanks, and many thanks giving us opportunity to make a little bit of tour about what topics are needed for AI, industrial AI, and what are the partners. I will start a little bit about why. I think it's quite obvious the why, at least for this auditorium village here inside the conference. Then a little bit what, how doing this, a little bit also, let's say, a little bit funny view, but also a serious view on it. But then, of course, how we are doing this. This is meaning touching a little bit the collaborative endeavor. We are touching all the aspects like Gaia X, also regarding how we're setting up AI communities. And last but not least, what's next? What are the next steps and so on in this content, more from the initiative perspective. And I have time, I have 2-3 examples, depending a little bit how far we are. So let's start. Now it's why. When you're looking here, this is some kind of growth of AI business applications over the next years. I used some data and plotted, so to say, my own graphic, but what you're seeing, it's increasing dramatically. Maybe, when you're looking to Europe, there's a lower curve. We have to look what we have to do. So the increase rate is lower. This is only a hint. And especially I was just jumping out from other conference that we have to look how we speeding up. Next topic is how is this distributed? Here are some kind of topics from IDC, some numbers about the AI spending by industry segments and the data spending by industry. You see this, not a surprise what is inside, but you see this is a significant portion. In a nutshell, and this is a little bit older slide because my boss is still here with the wrong title, so to say, because it's now Roland Busch, now CEO of the company. During this time, he was CTO. But nevertheless, you see here some statements from industry, IT, OT industry, in academia. In a nutshell, a big thing ahead of us. A really dramatic change will transform maybe our business, new business opportunities heavily in the next time, and very fast or faster like we're expecting. So we have to look for. What is it? What is behind? And what are the contents? And as said before, maybe a little bit a funny part, but I will come immediately seriously. When you're looking at AI application, and sorry, I've not seen the presentation before, but I can imagine that the colleague from Infosys catched all some of the elements, but I will transfer this also a little bit to the industry where I'm coming from, Siemens, my expertise in the manufacturing area. When you're looking at AI, you have on the one side, or AI application, you have on one side the perception. In this case, maybe you see a nice cat, then you are thinking about, that's the cognition part. Maybe you're using the knowledge, maybe this is dangerous, and then you have to decide. So meaning this is from us when we are to clustering the topics, let's say the components, This is, let's say, a little bit fun part, maybe not, but not so seriously part, but coming seriously, meaning in automation. And as I said before, I'm coming from this domain. You have on the perception side, your sensors, also historical data. You have the knowledge graph systems. You have the systems which you know how to behave, you should behave, and what are actual data. You have the cognition part. I will touch it later, where you have some kind of AI kernels, or in this case, a combination from a classical controller with a machine learning loop, and creating impact. Decisions could be optimization, like speed, flexibility, quality, efficiency, but, and this is maybe the more significant part, you can create something new business models, you can influence positive, you can create value for the society, environment, for the business, and so on. Also meaning really business driven. What you have to do is you have to put it somehow in a holistic view from the technology level, from the collaboration level, which you see on the right side. I come later to this. From the technology level, you know, you have the connectivity, you have all around to get the data, to handle the data. So you have the data spaces, you have to compute the data on edge, on a cloud, and you have to create value out of this for the topics maybe like seen before, optimization, but also for new business topics. In the middle, you see here, let's say, the schema which we are using, and I will go later also a bit in this AI framework, which is in the middle, the yellow blue box. But nevertheless, on the top, and this is coming from industry, it's important to create value, to create new revenue mechanisms, you create new businesses, and so on. Also meaning the impact, the business part, like described before. And you cannot do this alone. You see this on the right side. In a symbol, we are showing a little bit the schema, but because you have to do it, let's say, jointly. That's bringing me directly over to the how part, how we are doing this. You know, this is a little bit, and that's the reason also why I mentioned my a little bit collaborative endeavor. You have here some kind of, and you can find more, it's not complete, but you have somehow who's the user, think about the value. What are the data, the areas where it is, what is the network, startups, academia, established companies, new companies, small and big one, and what are the regulation or standardization part. And I will also touch briefly later, because yesterday by chance was a new AI regulation published from the Commission. I will also give you some words about this. So what I do, I'm just going with you through together through this, let's say, through the different dimension. Let's start with the user part. This is the left part on the lower corner. You know, in AI, you see this on the left side, a lot of possibility you have, meaning generative design, where maybe before you simulate this, can pre-select topics before you simulate it, because simulation costing a lot of time. So meaning you can use this. You can use this, for example, quality inspection. I can tell you, we use this in our own factories to look, is this quality check maybe with an X-ray system needed or not, or do you know the complete data to elaborate if the inspect is needed or not? Also by keeping the technology level. And I will not touch this in detail for the autonomous system. Hopefully I can show you later one example. For sure, applicable in different industry. This is more the area where we are coming from, or I am coming from, but I think it's not a surprise. Second issue, you have to think about what you need. And we have here, we named it machine intelligence kernel or core, MI core, where we have on the one side, and remember my first slide regarding knowledge graphs and knowledge part, you have the modules, machine learning, you have to train data, the models, you have to deploy this, maybe on a specific hardware, maybe also on a specific AI-enabled chip, and you have to produce the tools. Meaning you have an environment where you're using AI, and now I want really to put you a little bit on the right side in the corner, when you are only to give you some kind of feeling. And here you have this example from the manufacturing side, you have the classical control loop, PID controller, from manufacturing knows this very well. You can extract data, there's a data store, you can add additional data, you can make machine learning, you can make the machine learning several times and putting back in a controlled way new policy parameters, for example, let's say parameters for this PID controller, which of course giving you an optimal array and optimization and some output, because at the end is somehow to improve something. So meaning only to show this and this in a real application that you can add on, let's say, existing application or existing mechanisms, topics like machine learning, and really improving the processes. But as you know, depending on the domain, in this case, to feedback in a controlled way, because everybody knows us what is machine learning is and what we have to take care for in a controlled way, feeding back the information. Other issues, data, all is about data, and only to give you a feeling, and because I'm also vice chairperson of the GAIA-X Association, really brief insight what is going on here. You know, we are looking on the left side about data spaces. You see here for different domains, health, manufacturing, agriculture, energy, and financial, and so on. And so meaning how we can setting up a data space. When you go to the right side, you're looking how this federated edge cloud aspect, because depending where you want to deploy it or where it's needed to deploy the system, how you want to exchange information, you know, you have here this federated aspect. And this is in the middle, you see this famous X from GAIA-X, where you have on the upper side the ecosystems, the data systems, the applications, the verticals, the lower side, the more red one, the infrastructure, edge and cloud, for example. And in the middle, this federated services to make this happen on the one side, to give the data spaces some kind of environment, secure environment, sovereign environment, or on the other side, also this interoperability aspects, which you see on the right side. Next topic is, and now I'm coming to the more to the upper part of this ecosystem. You know, you have also to test this. This is an example where I'm on the European level active, where we set it up across Europe, some kind of iSpaces, we named it, the infrastructure, digital innovation hubs for big data. It's maybe better digital innovation for big data and AI. And you see here, and this is the right part, upper part, one highlight or one focus on the in Karlsruhe and the Smart Data Innovation Lab, where we're really bringing together the providers, the researchers, making something together and foster innovation. Only to give them feeling, we have to do it together, we have to improve it. Like mentioned before, and now I'm coming to the upper side on the right corner, left corner, above side, about standardization and regulation. I started here with a regulation. Maybe it's one or other knowing there was some kind of high-level expert group looking at artificial intelligence. As said yesterday, and this is a snapshot from this document, it was published a new regulation or AI roadmap, AI planning roadmap, where using also some kind of risk classes. Then you can elaborate a little bit in which risk class your application is falling. That's on the one side good, because it's giving also some kind of acceptance for the society and also some transparency. On the other side, we have to be careful that we are not over-regulating, because then on the other side, you know, this can falling also, let's say, not so good for us. I'll give you one example. When you have a drive optimized, and this drive is pushing form and conveyor belt in a factory, we optimize the drive to make it more efficient, more output. You can do this with some kind of reinforcement learning, like mentioned before. That's good. Of course, when you use the same drive in a robot, which is used in a clinical environment or helping people, then you're falling for sure another risk class. Meaning good, but we have to look how we adapt this and how we are using this. The other topic is, and also speaking when you about AI data or data exchange, data spaces, then of course the other topic are, let's say, standardization activities. you know, you have on the left side a brief overview about some of the standardization activities from ISO, IEC, IEEE, or also CENELEC. You see here on the right side also some kind of AI standardization roadmap, which was published some weeks ago, some months ago. But you're seeing also this aspect besides regulation, because when you're coming from industry and thinking about an use of AI application, data exchange in different domains and so on, you have to target also the standardization aspect. So this is, let's say, beside regulation, also when you have to scale up, you have to look how the standardization to get a broad use, broad exchange outside. Here's a little bit of complicated build. I will show this also briefly, but you see also major research, standardization activities are somehow involved inside in some kind of coordination, guiding standardization activities, but this is really some kind of food for thought, and I want not to touch this in detail. What's next? And now I'm coming a little bit to the back to my presentation, to the end. What's next? As said before, we are setting up here some kind of AI framework. You see here on the bottom side the technology parts, but also think about more words, how enabling new businesses and the value part. This is on the one side. When you're speaking about Europe, also, and I mentioned before, Gaia-X has spoken a lot of AI, data hubs and data activities, AI activities, and also accelerators. I try to somehow to put it a little bit together, where you're speaking about the compute, hardware, the connectivity, Gaia-X, prominent with data spaces, data exchange, AI application, and of course the verticals, you know, like Industry 4.0 or Catena-X, where it's going into automotive industry. All this we have to bring together, and not to touch here some topic. For sure, when you are speaking in an environment where I'm inside in manufacturing, then besides, let's say, all the aspects which are covered before, we have also to look in safety, reliability, resilience, real-time topic to get it done. Very brief, 2 applications, and then I'm on the end. This is some kind, we're in a machine tool optimized way, depending what good is produced. The tools are optimized in a way, placed in a machine tool magazine to speed up the production. Other example is here, and this is regarding autonomous systems. On the left side is here a topic where you're catching elements and have some kind of reinforcement learning in the background to get it better touched. On the right side, the productivity you see here, autonomous production parts are placed inside, and the system is learning during the production how to optimize this in a way. And last but not least, and this was my last slide, it's not all about machine learning. This is an application in CERN, Large Hadron Collider, where we make some kind of detection of events, alarms, and again here improving the availability of the machine. That's all. Quick overview, hopefully touching the right topic and then giving you a little bit of an overview about the endeavor or collaborative endeavor, like the title of my presentation was.
Thanks a lot, Mr. Hahn. I think this was a very interesting overall overview of the Siemens view on industrial AI and what's happening in Europe and also the world. I just will address one question to you, which my opinion perfectly summarizes your considerations. The question is regarding B2B in general or industrial AI, regulation. You talked about regulation, about the legislative scheme for AI, which has been published yesterday. Safety and safety issues, standard issues have a long history in B2B in manufacturing. So what do you think? Does this European approach will end in a global uptake for Siemens, for example? Siemens is operating all over the world. Is Siemens implementing those things which they need to implement for Europe, for the European market and the whole world? Or is it more a cost factor just for the European market to access this European market?
Yeah, you hear maybe my side comments. We have to make it in a clever way. Of course, we want to use it worldwide because we are worldwide present, but we want not a regulation which are, let's say, we can use this as a business benefit, so to say, but we have to look carefully on it. And you're just touching one topic regarding safety, functional safety, make it precise. For sure, we have to look when you have in a regulated industry a machine which fulfill functional safety. These are rules, machine rules, marine guidelines. That nobody is hurt or the system is running in a correct way. And you put some insight regarding machine learning, for example, as meaning you're changing the machine to make it more efficient, but you have not much at the end the machine which has at the beginning during the commissioning phase. And this is the topics where we are looking inside, and that's the reason why this risk class approach is okay. But we have really to look how this can be done and what it's in which risk class or which is anyway covered with functional safety or other regulation is anyway existing in our B2B industry.
Yes, I can just conclude that I totally agree that this, to really understand the deepness and of this regulatory proposal of the Commission is really important, and I think that will take a long time for all industry participants to really understand what this means in concrete and how this is linked to existing safety regulation.
Exactly. But you asked me as Siemens, for sure we are looking with the colleagues inside. It's not me alone, because it's good supporting the acceptance, but we have to look where it's applicable and where it's not anyway covered by other regulations like the functional safety.
Thanks a lot, Mr. Hahn. That was very interesting and a very interesting overview. And enjoy the Big Data AI Summit and see you soon.
Okay, thanks. Bye-bye.
Bye. So we just directly go to the next discussion, next introductory speech, which is also about industrial AI. Two colleagues from Trumpf. On the one hand, Dr. Tom Schneider. On the other hand, Karina Miet from Trumpf Machine Tools and from Trumpf are talking about AI applications in the factory of the future and how this is transforming the sheet metal industry. So we directly hand over to you, and we are very interested in your thoughts and considerations regarding those issues.
Yes, thank you for the introduction, and I think we would like to give you some insights on a very specific industry segment, and as a first starting point, maybe some words about Trumpf as one of the leading technology providers for sheet metal producing machines. So we have the laser cutting machines, punching, and including laser as a combination machine. We are developing our own bending and also the welding, and in a special case specific machines for the tube processing to cut directly into tubes. And all of these are connected for our customers in dedicated smart factories, where we would like to support them from directly from the start of the design until processing on shop floor, including logistics. And this we call TrueConnect, where we bring together hardware, software, and services. And today with Karina, who's one of the experts in AI at our team, we would like to give you the beautiful overview of what is done in sheet metal, and therefore we thought it's good to start with an overview of the end product, which we think is what we all have to drive together with applications based on AI. So it's various and very large overview on all the industries where sheet metal is taking its role as a kind of supporting element for design. So from automotive for e-mobility in the battery box, over consumer electronics, ventilation and heating, all the things where we get our lunch from, or the industrial kitchens are very have a lot of sheet metal, but heavy metal industry in construction and mechanical engineering in itself to design parts up to consumer parts and in furniture and lamps, and whatever is driven by AI needs switches and server cabinets. So, and these are also hosted within sheet metal. So the industry is big, and the process is always the same. So Today we would like to take you into our process world and give you a presentation where the AI supports our customers by driving their product excellence. And we have 3 areas where we would like to talk about. It's machine and automation, it's assistant systems, and at the end, connecting everything together in software and logistics solutions. And for the first detailed insight, I would like to hand over to Karina, because everything begins with the design, and it's the first step in for AI.
Thanks. So I will start with the example of Optimate. Optimate is an AI solution that identifies design errors and cost-intensive steps. And for example, we can identify if the undercut of minimum flange length is in a sheet metal design, and this can be identified and shown to the construction engineer so that we adjust this length to a suitable length that can be produced on a bending machine. Another example is the cutouts, which can occur close to the bend zone, and this can lead to deformations on the contour. And for this, we can include some relief slots so that this can be produced reliable and without deformations. And the third thing here is to avoid cost-intensive steps like the welding process. And with an intelligent sheet metal design, we can remove this welding process with 2 bending steps, which is shown on the right-hand side. So this right part is optimized with Optimate and is therefore cheaper and can be produced more reliable. So that's our first AI use case. And after the construction and design, we go back to our process chain. So Tom, what's next?
So after design and gathering the data, it has to be produced. And 80% of our customers are small and medium businesses with family having 4 to 8 machines. And cutting is always the first step. So after we have designed the part and optimize it by cost and processing, we will hand it over to our cutting machines. And in the very small businesses, we have in the last years developed an AI-based tool which supports our customers in the first process step. And that will be highlighted by Karina, because it's also something where the technology of cutting the part meets AI in the next, preparing the next process step.
Yes, I will present to you the sorting guide and the challenge that we have here. So with a laser flatbed cutting machine, we cut sheet metal parts from a huge sheet. And to use this sheet very efficiently, there are a lot of orders that are nested onto this sheet. And that's a huge complexity that the worker has to tackle in his daily work. And with this sorting guide assistance system, the camera detects a part removal and locks this automatically to the system. And it also assists the worker by showing him different colored parts. And by this, the worker can easily sort the cut parts to the next process step or according to an order set. And this system was recently awarded the AI Championship from the federal state of Baden-Württemberg. And in the next slide, I will show you why we needed AI for this. And this is basically due to the fact that we have a very versatile working area there. So it's a huge space. There are a lot of different conditions that can occur. So for example, we have different materials that can reflect the sun, or also the sun is shining through windows on the working area. We have a lot of different part geometries, or the person interacts with the working area. And all these things are difficult for a classic algorithm to cope with. And that's why we solve this challenge with an AI solution here. And I will show you this using the example of the sheet tracking, where we started with a classical computer vision algorithm. and just started to implement it and collected data from our test customers and did the normal data labeling. And then we could start training a neural network to do this detection more reliable. And this was also due to the fact that it was very hard to parameterize these classic machine vision algorithms so that they work reliable in all these different conditions. And we already showed in this example that our neural network is really robust and more reliable to detect the sheet position. And this is shown also here in this little example. You see the machine area and also the sheet. So for a human, it's very obvious where the sheet is. And now this AI system can reliably detect all the parts that belong to the sheet and which are metal parts, for example, and also what is just apart from the machine. So Tom.
So and that, with the handed sorted, and I think we have to speed up in the application of AI, but the next thing is speeding up the process chain at our customers and coming to more autonomous driving. And maybe we give the auditorians a short insight of how AI in autonomous producing machines is currently supporting our customers.
Of course, I will introduce the example of our fully automated TrueLaser sensor system. And this system has an automation unit which removes the sheet metal from the residual sheet. And here you can see a not so successful try of the machine where the part gets hooked in the residual sheet. And this is due to a complex problem, namely the precise position of these shuttles and together with some pins that come from below. And this is an optimization problem, which is also shown here a little bit more schematically, because we have to define in advance where these pins should be placed in a very complex geometry. And if you put pins only on one side, you know that parts can tilt or something. And so by each part that is removed, we always save the combination of pin and shuttle placements, and the machine can detect whether the part removal was successful at first, second, third try, and so on. And if it fails at the first time, the machine is so intelligent that it can adapt the positions of the shuttles and the pins so that it tries again in another composition. And this is saved and the basis for our learning algorithms in this machine. And so we create a very robust automation unit that is the first step into fully autonomous manufacturing.
So now we talked dedicated about the manual process by assistance systems and autonomous driving. And I think it now summing it up into a process chain where we see that the logistics is after our bending and welding part, the key driver of making our customers successful. And also there we have an application support by AI, which is, I think, worth to share today.
Okay, I'll dive into that. So we just introduced, like some years ago already, the track and trace system, which is an ultra wideband based indoor localization system. And it works like, similar to the known GPS, the global positioning system, where you have satellites that are attached to the walls of the production hall. And you have mobile devices that are attached to the orders at the beginning of the production flow. And with radio signals, you can triangulate positions, and thereby we can digitize the whole material flows in a production scenario. And this is a quite interesting use case for big data analysis, because we can use each position from each order over time in the production scenario to do some very insightful analysis. And this one, which I bring to you now, is a data quality analysis where we compare the EIP data with our automatically logged position data. And in this yellow rectangle box, we have the bending area of a customer site. And we looked into the EIP data, whether an order was now clocked into the bending process or not. And to explain this a little bit, it's still a very manual process. So the worker starts his job by walking to a terminal and clocks this order. And after he finished processing, he does this again. So it relies on the worker that he always really does this at the exact time. And if we compare this with the traces that we get from the indoor localization system, we see that there is a huge derivation. And for this specific customer, we had 83% of all activities that were not in the bending area, but somewhere else. So we see that there is a huge deviation between what is logged in the EIP system manually versus what we can achieve with an indoor localization system where each step is digitized automatically.
And now to somehow finalize our presentation of the use of industrial AI, I think it's giving ourselves in the position that we would like to optimize for our customers the full process change right before they are building up the factory, and there where all the information we have collected over the different machines and the different assistant systems come together. And this is maybe for the last 5 minutes a good outlook to see where all these came together.
Of course. So let's start this section with a little question at the beginning. So Chesco and sheet metal production, what do they have in common? And well, they have in common that they are all very complex planning tasks. So if you compare it with the size of the search trees, you see that the sheet metal processing environment is a really, really complex area where you have a lot of possibilities to optimize your system. And we compared this with the number of atoms in the universe, and you see that it's that we are magnitudes higher than this. And yeah, why is this so difficult here? Let me explain this to you a little further. So we have a really complex optimization problem, or yeah, there are two problems which are closely interwoven. So on the one hand, we have a packing problem where parts are nested efficiently on a sheet metal to minimize the waste that occurs in the cutting process. And on the other hand, we have a machine assignment problem where we want to increase and maximize the utilization of the machines. And normally we have like a stream, an input stream of orders where we have different parts with due dates and values. So this is similar, or it's just a basic job scheduling problem. But then if we nest it on the sheet, we define when it's available for the next process steps. And if we then see in the production that a machine has a low utilization, we have to go back and adapt the cutting. And then you can see that it's just a vicious circle. And if you optimize only on the one side, you get a bad result on the other hand. And what we did there last year with a student of mine, Alexandru Rânțiuc, we used the AlphaGo Zero algorithm to optimize our sheet metal production scheduling. And this showed some good results. So please check this out if you want to know more about that. And also Alexandru is doing a PhD in this topic now. So that's a quite interesting thing here. And yeah, with reinforcement learning, you know that you always have to have a precise model of reality, which you can use to evaluate your goal function. And this model is a digital twin for us. So digital twins and AI are a very perfect combination, and I want to show you why. So our simulation that we use in our digital twins is an agent-based and discrete event simulation. And this modeling paradigm is very nice to do AI stuff with it, because this agent paradigm is very similar to learning and training agents with a reinforcement learning policy. So that's what I showed you before already. And there are other important pros. So if you want to do data farming, for example, to abstract a complex simulation model, you can use this model and generate in and output behavior and train models to abstract this behavior with a better response time. And also you can play out the model to generate traces for rare cases. And the last thing is that you can also use these models and digital twins as test beds for your trained networks. And as you know, simulations are a risk-free environment. So if your AI does something weird, it only crashes the simulation and not the real production scenario. So that's it. Tom, please conclude why we have a sweet spot here with our industrial AI.
Yeah, so it's like we tried to convince you that it's a very nice setup to use AI in a real industrial environment, and we took over as a final remark that we take the statement from Alan Kay, and people who are really serious about software should make their own hardware, and I think we would like to transfer it a little bit, and people who are really serious about industry should make their own machines, and that's how we would like to hand over to the audience again. And thanks for having the opportunity to present here, and everybody who's interested in follow up with Karina or myself on how we try to transform a specific industry with the help of AI, but also with a lot of machinery and still the domain expertise coming out of all the engineering schools around Europe and the world to have really the good starting point for AI, because it's the data coming out of the machines and being used to support our customers for better products. And that's a simple circle we would like to present. Thank you very much.
Thanks a lot. So there are a lot of questions in the chat, which shows to me that it was a very interesting presentation. So feel free, as the colleague said, to connect to the both of them. I think we have just time for one question. So there was one question regarding ecosystem. You just mentioned it in your final considerations, but can you give us some more deep insights into how you communicate results, communicate new operations you use at Trumpf to your ecosystem partners?
Yeah, so thanks for this interesting question. So the first thing is we are driving the initiatives like UMATI for an open standard and open communication standard for all machines, together with the colleagues of Machine Tool Industry. And we are also driving OMLOGS as an open standard for ultra-wideband communication and gathering data across industry and companies, because we think in openness. And finally, the pre-call talk from Siemens was about the European way of implementing Gaia-X and driving this in Industry 4.0 Alliance or the Catena-X activities. And we are part of all these activities. We try to transfer our whole industry in the kind of an open factory core, where we share the data to allow for our customers to do their own use cases and improve their production chain. And that's where we clearly think the future is. So we would like to have this openness and drive all we can do within the ecosystems, that the future of manufacturing is driven by AI and data with good machines from Europe. So we try to do everything there. But it will be a long way.
I think that's a perfect final statement. Thanks a lot to both of you for this very interesting chat. And as I said, feel free to connect to the two colleagues from Trumpf to interact and to discuss in depth during the Big Data AI Summit today and even afterwards. Thanks a lot. See you.
Thank you very much and have a good day. Bye-bye.
Bye-bye. So we are directly jumping to the next presentation, which is about AI applications in the context of personalized therapies. And the presentation is being held by Dr. Ralf Angermund. He's therapeutic area director at Janssen Cilag, Germany. Then we have Professor Dr. Thomas Neumuth from University of Leipzig, and he's CTO also from ICAS. And finally, we have Laura Wamprecht. She's managing director for Flying Health. The stage is yours.
Thank you a lot for the invitation first, and of course also the moderation. So as you mentioned, I'm Laura. I'm from Flying Health. We run an ecosystem for next generation healthcare, where we try to combine innovators such as from research and also from startups, but also to combine them with the corporate side to bring innovation to life. And I'm very happy to have the session here, where we demonstrate a particular use case and a very particular project where it's about how we treat cancer in our society and in the future. And I have two guests, which definitely represent both the medical part. So this is Ralf Angermund. You are a trained oncologist, so you have also the experience from working directly with the patient, so you know all the medical details. Now you represent the oncologist part at Janssen, which is a pharmaceutical company. And on the other hand, we have Thomas Neumuth. So you are the professor, you are the techie guy here. You know everything about computer science, and you joined forces to create a common project which is about cancer treatment. And to give the audience a better idea of what we're talking about, I would like to directly hand over to you, Thomas, to illustrate what is the project about, what is the use case, and afterwards we go into a short discussions and think about where can we be in the future.
Okay, thank you very much, Laura. I start sharing my screen of the presentation. Okay, so yeah, thank you very much for the invitation. It's a pleasure for us to present this project here. We call it the KITE project, or the KITE platform. You see, it's an acronym for Knowledge-Driven and AI-Based Platform for Therapy Decision Support in Hematology. It's a joint project with Janssen Cilac, one of the big pharma vendors, and we are happy to show you a new way how we envision the future of hematology might look like. And so, yeah, and I'm starting with the introduction of the platform and of the technology. So when you work at the intersection of data-driven methods in medicine, it becomes clear that it's nearly impossible to search for a one-size-fits-all approach. So of utilizing, for example, AI in the clinical context, because most of the clinical fields are very specialized and individual, and then of course you have a lot of varying patients and patient-specific parameters, so to say. The application field of our approach is the field of hematology, and in particular hemato-oncology, that mostly deals with pathologies of the blood in the bone marrow. And so the input data we use come mostly from laboratory findings, even down to the molecular level. So we deal from the technical point of view mainly with structured numerical data. Those interpretation of those data require usually a lot of clinical knowledge and experience. And to address this, that's a lot of clinical knowledge and experience, we designed this platform. Of course, all this highly specialized testing of the data coming from the labs requires a lot of expertise, but also the right facilities. So a major university hospital might do all of this in-house, but an oncologist in a rural area might have no timely access to all of these resources. Additionally, there might be as well a lot of difference when it comes to the consideration of the latest knowledge about the field, of the latest research to take into account for the therapeutic decisions. So imagine that large hospitals are often very active in clinical trials and research themselves. However, for a rural physician, this might not be the case. This situation introduces an imbalance, a potential imbalance in the treatment quality of the regarding the state of the art for the patients, and the imbalance is caused, as mentioned, by available resources, by the knowledge, and by the information access. And here our platform targets this problem. So with KITE, we aim to overcome this imbalance by applying a holistic knowledge base about specific hematologic diseases and apply AI algorithms on top of those models to bring the power of data-driven medical evaluation to every user, to every clinical user in the same way, and to establish the same level of knowledge for all. What we want to achieve is to calculate, to propose an optimal treatment decision based on the individual patient profile. So what means optimal treatment proposal? this has different perspectives. One perspective is, of course, a very effective treatment. Another perspective might be treatment without severe side effects, for instance. So it's also an important topic for the patient. There are different perspectives on this, and we try to accommodate this. The KITE system uses different knowledge sources to calculate, to support the calculation of the patient individual state. You see here we have three general, let's say, sources of information that represent medical knowledge. So the first one is clinical guidelines. So these are consent-based documents, so to say, that states the current state of the art of the treatment of a patient. We have large databases for retrospective medical case data about previous treatments, and of course we have published evidence from clinical trials and from different medical publications. On the technical level, we implement a proprietary ensemble approach, which we developed with the goal of being explainable. And this is one of the major messages also of this talk. All we do for the clinician needs to be explainable and needs to be back traceable, and to follow, to make sure that it's the right decision. At its core, we use causal knowledge models that enable us to formalize the medical information and identify individual decision points. Along the way, a therapy decision is made, and for instance, for calculating medical scores or for interpretation of therapy-related outcomes. And currently, we have a number of leukemia-related diseases, each featuring several hundred individual information about one patient and several thousand relations between this relation that would a clinician need to consider during decision making. And here we have our we settle our approach to enable the clinician to make a patient individual decision, but on the other hand to take into account the general worldwide recent knowledge about the treatment for the patient. So this is the objective of the KITE system. The system itself is based on different decision steps that all, let's say, are like a chain. We call it a decision trail, and we pass on information from one step to the other. So we do this to minimize the error propagation, so that not, let's say, influence one error of in an early stage the final decision, and also, of course, to make it traceable from the backside. So with the system, we contribute to the goal of providing equal information supply to every medical decision maker. So no matter which resources are available or where they are located, and we pay special consideration that we do not brute force AI applications into the current clinical process, but it's rather intended to work as a kind of assistance. So it supports the clinician. It doesn't replace the clinician in its work, and that's the way it should work. For experts, the main function will be complemented by further active collaboration functions, such as the possibility to organize virtual tumor boards. So tumor boards is one part of the medical decision-making process, so that you involve multiple clinicians into a decision to make sure that this is the right decision and that it has approval from other people. And this is also a relevant topic to share this information using the KITE systems. And finally, for the patients, to be sure that that the case is evaluated and that he really gets the best available therapy decision, the best available knowledge is included into his decision. This is the final point, and this is how we envision the the system to work. So imagine, as a final sentence, the power of, let's say, 1,000 doctors into one system, available everywhere in the world at every time. And that's how the system should work right.
Thank you a lot for introducing the project. I think I really like the last sentence to demonstrate where are you going? And this is what I would like to take to Ralf. So you are the pharmaceutical company who joined the project. So what was your main motivation and how was the collaboration between the two of you?
Yeah, first to start with, for example, it's one of the main goals as a pharmaceutical company. We at Janssen, we want to make sure that the right patients get the right therapy or the best therapy. That is a kind of personalized approach. Let's give it an example. It's because it's easier said than done. For example, one of the diseases we are dealing with is a disease called multiple myeloma. Picture yourself 20 years ago, we had five drugs maximum to treat. That was pretty easy to treat. Unfortunately, the prognosis was very poor and the overall survival was about 3 years and roughly no patient lived longer than 5 years. Now, 20 years later, we do have about 20 different products on the market. We do have a median over survival of at least 9 to 10 years. We do have patients being cured. In the past, 20 years ago, 0%. Now we are coming close to 8 to 10%. That is a huge difference. And we want to make sure that every patient who has the option to get cured and not lost somewhere in the system. That means nobody knows what is the best treatment. We have basically medical decision-making is based on two parts. The one is the evidence known and the other one is experience. And the evidence is so huge and so complex that only the top experts know this. In order to bring it down to everybody, as Thomas said, to every physician out in the field who is not the top experts, we need to make it usable for them, and that is the goal of the project. So for us, that was when the idea came through from the University of Leipzig. It was a nice fit to our approach.
And what was maybe your key learnings? What came to my mind was also the question about how you create trust. So both for the physician and of course also for the patient.
Yeah, we had some examples in the United States, for example, where there was some AI which did not get acceptance by the doctors, and the question is, why did it not? Wasn't it accepted? And the answer was it was a kind of black box. Yeah, so you put all the data in the system, and the system comes with an answer. And as a doctor, you need to be responsible for the therapy, and you need to understand why this therapy is the best therapy for the patient. And that is what Thomas said: the explainable artificial intelligence, the explainable. So that is the nice thing, what we've learned, that it can be done. It is not that complex that it cannot be visualized to the treating doctors, how the decision or the recommendation, or it's not a decision, it's a recommendation from the system is made. And that is so nice and so beautiful. And this is something which we believe this will gain trust in the environment.
As you just mentioned, the United States, what we often learn is that some project might be easier in the US because of maybe data regulation or the availability of a lot of data. Now we are here in Germany, but you still did it. You started this project. So maybe you can give also some idea, why is Germany maybe also a good place for starting this kind of project, and where do we have room for, let's keep it improvement. So where can we do better?
Yeah, so first of all, the environment is brilliant. Yeah, the close cooperation between the clinicians in the Leipzig University and the ICAS, for example, that is something you rarely find. It's really difficult to find in the United States, because the United States decision-making process was made by IT companies. Yeah, and now this process is done by a corporation, Thomas. You can speak better to it, because that's a close cooperation between clinicians and the IT experts. That is good. What we need, and what we need better, just to give you a short answer on this, the system needs to learn on real world evidence, how to get there. To get there is, we do have normally the patient records. Do the patients behave as expected? We don't know yet. We need to get these informations. And that is the learning system. For this, the Struct, we need to create some electronic health records which can be utilized. And that's a data protection discussion. That's a way how to anonymize data, and all these kind of stuff needs to be addressed. But I think the environment is good in Germany to bring it forward. But these topics needs to be addressed.
Yeah, so and we also have an upcoming election in autumn. So maybe to wrap up also our session, and I would like to start with Thomas. If you would have a wish, also as a scientist and when you have universal background, what do you think should the next Minister of Health should set on the agenda to keep also AI in healthcare move forward?
I would start from looking backwards. So let's imagine in so we're currently in a transition stage, but from a kind of old world, analog information, paper-based systems to the fully digital world. And if I imagine to be 20 years in the future and look back, then I would ask why it took so long. So what was the problem? And we need to maybe to think from the back and side and to think about how to accelerate this project, because all data we are currently not transferring into the digital world will be, to be honest, will be lost. So no one will analyze the paper-based records.
Then the last sentence also with the same question from you, Ralf, also as a physician and then also from a pharmaceutical point of view.
Yeah, I think we have to state that we have one of the best health systems in the world here in Germany. And we need to make the information we have in the system available for generating further evidence. If we could make this possible, yeah, that would be great. And that is unique probably in the world, and it's on the same level in the United States. That's the electronic health record. That's the data, find a way to get the data protection. And that's in line with what Thomas already said. Yeah, bringing the data we have at hand to use for everybody.
Thank you a lot for having this session here. I hope that we were able to demonstrate to the audience a quick use case on how we could improve healthcare with using AI. Thank you a lot for your participation.
Thank you.
So thanks a lot for those very interesting insights, and feel free to connect. We have a few questions in the chat. Feel free to connect to the presentators of this slot regarding this very interesting presentation of individual-based medicine based on AI. So we're directly jumping to the next session, which is presented by Christian Umbach. Christian Umbach is co-founder of and CEO of Xapix, and he's talking about democratizing enterprise AI, leveraging the power of ML around platform use cases across different industries like manufacturing, Industry 4.0, mobility and real estate and retail. So the stage is yours, Mr. Umbach.
Perfect. Thank you so much. Hello, everyone. Very nice to spend the next 20 minutes with you. I'm excited to talk about a little bit of our journey, as hopefully also the slides will be coming up here, which is essentially around democratizing enterprise AI. And it's a topic space that we can also see here in the summit is talked about a lot. I would like to really make this specific to 4 use cases that we've been working on with our customers here at Xapix, but also building on broader experience, whether it's from the academic side or work across the industries from everywhere, from Amazon to different automotive companies, different manufacturing companies, and others in the space. We want to make this a little bit hands-on, so Nico from our team will drop a question, a little survey in throughout the session. We'll be curious about your feedback there, and we'll get right to it right now. For us, what we started with was really an API-based approach 4.5 years ago. With Xapix to essentially build the basis of making data flow. But for us, it has become the basis of essentially building and scaling a company that now puts enterprise AI very much in its core. And if you look at the systems around us, the environment that we're in, it's not the technology in the end that is driving the pace. The business is very much driving the pace of adoption. And the business may have requirements around new digital business models, new ecosystems, the integration of environmental, social governance data, for instance, in the direction of sustainability, or the pure pressure to perform and to survive the next the next fall, because everyone's going to be shopping for Christmas and they really need to provide a good shopping experience and have the inventory ready, or actually launch the models and the services that have been on slides for a couple of years now, and bring them to market and really deliver on that promise. Companies today fall in the entire spectrum, from being very nascent to being obviously ones that have maybe been working for 10, 15 years on the topic space. And in our session today, we want to highlight a few elements, because what I feel strongly about is that the topic of AI and the benefit from AI can be leveraged along the entire spectrum. But at the same time, democratization means that everyone has access to it, which I think today in the market is not necessarily the case, not because the technology is not out there, but because the link between the business side and the technology side is sometimes missing. So when we say enterprise AI, what we mean by that is essentially looking at 3 different steps. The first critical part is the unification piece. Unifying data, making data flow in that sense, is the underlying basis of any activity that you want to realize. There are a lot of companies out there, I think, a lot of teams which start with the model. They want to build the perfect AI, they want to build the perfect model. And I think it's unfortunately it hasn't proven to be the right way to approach the problem, because while they may have the perfect model, it doesn't get the real data in production. So that's one of the reasons why the stats already. 87% of projects in that field oftentimes fail because they fail to deliver the return on investment. So we feel strongly that it starts with making data flow, and it ends with the connection piece. Connecting the enterprise is key to, again, have that end-to-end flow. And then in the middle, you can actually start introducing machine learning models, again, as a evolutionary path, maybe starting really from like simple models, even simple functions there, and then being able to get into very comprehensive models. And we'll have a few examples around that now. So if we zoom out of those 3 steps a little bit, really what we're seeing in this picture here is going to carry us a little bit through the presentation overall, is essentially the necessity, obviously, to connecting real-time systems, and more real-time systems, whether it's from sensors, whether it's just the magnitude of data that is passing through and is being provided from both newer systems, but also more legacy systems, depends on what you're connecting to. And then when it comes to machine learning, actually leveraging the property that machine learning models today, in the vast majority, can be made accessible through an API. And for us, we've built comprehensive tooling around that to just bring that into a no-code or low-code setup, where you can just plug in your model in that context. And then in the end, your model should be doing all the magic that you've designed it for. But the core value then really is only realized if you manage to integrate it and distribute the outcome to the specific target systems in the enterprise. So before we really dive into the 4 use cases, what we're curious about, and kind of your input on that, is how far along are you with your team, with your organization, about the topic today? is that only for big corporates, which maybe started a few years ago, and or are you much further along? So you'll see the link in the chat, but also here on the slide as a reference. Curious about your feedback there, and then we'll keep you in the loop on the results around that. So let's dive right into kind of the 4 specific use case categories, and we're going to start with retail. Really, the journey that I would love to take is giving you a little bit of the insights on the specific challenges, and like through that also seeing similarities across the industries. So the first one here is in one of the most exciting fields right now in terms of speed and velocity, the aggregation of e-commerce sellers, e-commerce firms. You can, if you want to dig into it a little bit, it's usually in the fulfilled by Amazon business. There's a huge industry coming up, which is buying up individual sellers. And in the end, what the challenge that these companies are facing, what it boils down to, is both common organization. You want to bring together different approaches, build a common data model around that, build a common process around it, but also then build really intelligence into that process such that more and more automation can drive it, and you're actually able to keep up with the complexity. There's no chance that you can steer 10 million, 20 million products across different sort of brands and sellers that you have aggregated with traditional approaches. So machine learning is key for you to actually be able to have a somewhat solid foundation for the business. And for these folks, what in the end, what matters to them is logistics optimization, ad optimization, product pricing, but also even figuring out the right financial information in that context. And while maybe some of that information isn't as real-time critical, the pure mass of information here makes this a very solid technical challenge as well. And one of those drivers around the technical challenges is the complexity of channels. In this case here, think about a company that wants to distribute through Amazon, wants to distribute through Facebook Marketplace, through Shopify marketplaces, and so forth. In the end, to do this effectively, they're communicating with the APIs behind all of those marketplaces and are now aligning these processes and bringing in intelligence. The picture that many of them sort of initially faced was kind of the spaghetti here that is shown. So really a complexity that was hard to manage on their way, while they actually want to rather focus on the right side of the picture, focus on the business outcome and around logistics, ads, and so forth. So the process here that we're advocating for is really starting with a view on unifying data. So going from a single channel to multi-channel, having the ability to take a defined data model, take it across those channels, even though the underlying channels themselves may have variations in that. That is key to embarking on that process. The second part then is around connecting the enterprise. You want to have the data actually end up where your teams need it, in a data warehouse and an ERP and other systems. And only then the third step is really bringing in further intelligence. Maybe initially just a logic, a rule-based function, but then leveraging that into building out more insight there. Now, let's accelerate into manufacturing. Somewhat similar picture, different context here. But again, we can see that the complexity starts with the ability to connect to different machines, cameras, and other systems on the manufacturing side, bring it in, bring it together, and then feed the right target systems with that around production data, repair order data, and so forth. I wanted to give you a quick example from that because working with customers in the field, it actually oftentimes starts with smart triggers. So what you can see here is an example of real-time data coming in and different triggers being set such that either the SCADA or the MES systems, which are manufacturing specific systems, are being hit and receive the specific results. Now, once you have mastered this stage, then it's time to go to the next stage, which is really pulling in machine learning powered automation now for the user here, and this can maybe be a product manager or even on the business side. This will look like something that's for them, it's actually not a big difference whether it's a simple function or a machine learning model, because what it's delivering for them is an insight into how their business should react in this. So what we can see here in this example, you have real-time data that's coming in, it's going to a model, and based on the result of the model, actually different actions are being taken. So maybe in this case here for our demo for the Slack channel, a warning is sent or a specific alert, depending on the results that are being delivered. Now, we've been building a use case with Bosch Rexroth around that. Bosch Rexroth and with their Control X product, they're experts in equipping production sites, factory lines with intelligence, so with both sensors, with systems around that. And what you can see here is a soldering furnace. In German, it's Lötofen. One of the biggest energy consumers in a factory today. And what we were able to show is that by not only taking data from that, but also equipping it with the right data communication with energy systems around it and other production relevant systems, that first of all, you establish that basis of making data flow, and then step by step, you're bringing in intelligence and building on that. And we've seen great results together on that use case. And really the way we think about it on an, I guess, specific level here is, again, the data that is passing through from the system has different actions, different notations that you want to realize with it. Sometimes you want to update your data sets, you want to train your model, you want to kind of train the prediction, actually posting the prediction. This is probably done here, the production usage of the model, and obviously check against the performance to see how your model is performing. There's a lot behind that. I'll spare you the complexity right now. Let's dive into mobility. Again, our favorite flow here that we're seeing again. You can see it's that again here it might be the real-time data that's coming from the vehicles, from trucks, but at the same time may also be coming from mobility services providers. The use case here is much more around fleet management, around digital offerings. And I wanted to share with you a use case we presented with Goodyear, which was already almost 2 years ago here. But the ability to essentially connect consumer fleets with a new service offering that they launched was very much based on the ability to connecting the different mobility services provider, connecting the different vehicles, and then bringing in intelligence into that flow to really turn vehicle data into something that helps them identify like what's the right job to deliver on and what is the right service for the customer to realize. And finally, the fourth example is coming out of the real estate world, where now the systems that are being connected here, obviously both the traditional real estate systems, sometimes very custom systems in the industry segment here, but also increasingly real-time sensors in the assets. And if we take a step back and think about what do companies here actually want to realize, there's a lot of regulation coming into the space, and similarly, at the same time, a lot of awareness to build and invest in more sustainable assets. And that's so environmental, social governance, compliance appears really at the forefront of both funds, but also the operators of those businesses. So having the ability to manage the data flows and then here again, bringing intelligence is key. And we have an example here from Stefan from HIH group, who shared this last year, where based on the tooling that we provide them, but initially built an integration layer, but then on top of that really realized what they framed as a digital real estate passport service, which is in the end machine learning or AI powered ability to figure out the right performance, the right forecasting for the real estate space, and bring in essentially the right additional data to enrich it and to really explore the right connections. The point that I wanted to make with kind of this session today is really about, it's an exciting space, but it's more than just models. And I'll pull in an overview from Gartner here. Having effective enterprise AI initiatives requires more than machine learning operations. It requires the full flow between data operations, machine learning operations, DevOps, and we've really seen the need of that come together, which for us, and this is going to be kind of my final slide here, brings me to this picture, which is, it's not only about the brain in the end, which holds the kind of the smartness, maybe it's representing the model here to drive the decision. It's also about the spinal cord, because only with the spinal cord, only with the ability in the enterprise to push out the data and to connect the data, you're actually going to get the brain to talk to every single part in your body. And I'm curious to have a conversation with you around where you are within your organization. We've made some of our products available to the open community. If you want, you can try them out. Otherwise, feel free to ping our team with feedback, curious on a deep dive. And I thank you for your time today.
Thanks a lot for the presentation. I think we have time for one question I would like to address to you. You were talking about democratizing enterprise AI. So could you give us some insights in how companies who don't have experience with data a lot, with AI a lot, how they, when they use your platform, how they build their own within company ecosystem, within company knowledge based on in the cooperation with your ecosystem or your platform?
Yep. So the democratizing part really goes back to a key fundamental parts. One is price point. Like a lot of organizations don't have 5 or 10 million to spend for their first big AI project. And that's, for us, what we see is that by actually identifying a few key systems to connect, they can already start with initially quite simple automation and then understand much better where to specifically spend and connect. And it's at a price point which is 10 to 100 times lower than what a traditional AI company would probably come in with. The other part is really about the focus on no-code and low-code components in the tool set, because not everyone needs to be an expert in a specific field here. You can't be an expert in data ops, machine learning ops, and DevOps at the same time. So leveraging low-code components actually makes this topic much more open to companies and to teams in general, because you can bring in your specific knowledge while we essentially help augment and you could say automate the flows around that then, such that it really becomes much more accessible as a tool, as a platform for the teams.
Thanks a lot for the presentation, also for your considerations regarding this second layer. Thanks a lot for the presentation. Feel free to connect to Christian Umbach in the following parts of the Big Data AI Summit, and see you soon.
Thank you.
Bye.
See you soon.
So we are directly jumping to the next next presentation, which is being held by Dr. Bernhard Niedermeyer. He's head of emerging technologies at Cloudvoid. Light, and he's talking about cost-efficient AI technologies, and in this context, why AI platforms could not be enough AI platforms in the market, as the competition is generating new values and insights, I guess. So we are very interested in listening to your considerations regarding these issues. The stage is yours.
Okay, thanks for the introduction. Hello, everyone, even during lunchtime. Thanks for joining me also at that time. I have had a quick look at the participants list, and I've seen there are several or many data scientists amongst you. There's a quick warning. My talk will not be a really technical one. It will be whether a talk on the strategic level or on the requirements engineering and business analysis level. So hope you will nevertheless enjoy it. If you afterwards have more technical questions, please reach out. I'm available for anyone to contact me. So who am I? Let me quickly introduce myself. My name is Bernhard Niedermeyer. I'm involved with machine learning for almost 15 years now. I've started in academic research, where we've been applying machine learning techniques to audio processing. To precise, it's been topics like when you've got an audio recording of a piece of music, you want to find out and identify the notes that have actually been played, and other topics like music recommendation, music similarity, playlist recommendation, and so on. I've joined the private sector in 2012 at Cloudflight. Cloudflight is a custom software developer. We're about 400 people at the moment. We're starting at the consulting part, where we identify together with companies how and where to apply software and AI, in particular to their business processes, where you have really a distinguishing value out of it, and then of course design and deliver and also operate those solutions. I had the honor to build up not only a team but really a business segment around AI from scratch, which has been going obviously in the last years as the topic became more and more relevant. I'm really sorry that we can't meet in person due to the general situation, but I've put my contact details here, and once more I want to emphasize that I'm really open. If you have more questions afterwards, please connect and just reach out to me. And with that being said, let's start with the actual talk. And it's really a motivation towards machine learning platforms and towards professionalizing machine learning up to the level where, let's say, classical or more traditional software development is already. To give you more of a motivation for this, I've put a Bitkom survey here about the usage of AI in Germany, and you see it's in use last year at 6% of all companies. You see a very good increase in there. But to be honest, we're data scientists, so let's have a look at the data and at the visualization. And when you put the visualization a bit differently, when you normalize the scales, it doesn't look too optimistic or too good though. And 6%, it's quite a low number given the high potential of AI, and given the circumstances where many talk about AI as the new electricity, enabling so many more applications on top of it. So why is this the case? And thanks Bitkom for also asking that question in your survey, and asking companies why they have not been applying AI yet, and why it's not in place there. It turned out when looking at the top 3 reasons, about a half of the companies claimed that they don't have the right team to introduce AI. They don't have the skills. And an easy answer to that would be to just ask you to come to us or to other service providers. who help you to introduce AI, but that would be too easy, to be honest. And it would also, from our point of view, not solve the topic. As also we are struggling in hiring enough people who have the right skills. You know, the labor market is also difficult there. So our take on this is to really lower the entry barrier into AI. So instead of course, education and training is very important, but it's not the only measure that needs to be taken. The other measure that needs to be taken is to really enable software engineers who have not the deep knowledge or not the long-term experience in AI to also apply those techniques and to also get into this field. And our vision really is that in the near future, every software development team will have AI skills and AI knowledge on board. And to enable it at that scale, you really need to work on the entry barriers. Another reason, number two reason for not applying AI is no time. Here you need to differentiate a bit whose time we're talking about when we're talking about the time of the developers and the data scientists. We're coming back actually to the first point. So by lowering the entry barrier, you might have more people who are able to work on these topics. But on the other hand, another aspect here is speed and efficiency. So we also, as another reason for introducing platforms, we see an important leverage in just speeding up teams in what they're doing by taking away routine tasks from them in data science also, and having this managed by a platform. And this also applies to the third reason, namely no budget. So also, in order to make AI solutions cheaper, we have a very strong claim towards introducing platforms. Also regarding that third point on budgets, let's have a look at the economics of AI, and don't get angry with me because this example is really trivial what I'm saying here. But bear with me until I come to the argument. When thinking about AI usage, we need, of course, to think about the value it has for the user, for the company who is facilitating it. And when you look at a large, let's say, insurance company with millions of insurance cases per year, when you save only a minute per case by an AI system, that gives you a lot of a leverage. When you are a medium enterprise only, this draws a completely different picture. And this makes us as a service provider struggling. Why does it make us struggling? Because for many companies or for many challenges, we do see AI solutions, and we do see solutions where we say we could develop this, we could train this AI and it would help you, but to be honest, it wouldn't pay off for you. The ROI calculation would just not be a good one. And this is where standard products have their place, but when you really at your core business where you need a customized and individual solution, then this becomes an important topic. And this is a point where we see many AI initiatives being stopped, unfortunately, because of that ROI, which again brings me to the point that AI just needs to be cheaper in the development and much more efficient still in development. What's in the line of the argument, how can we make it cheaper by standardization? And AI, as you know, there are many fields that are still under ongoing research, but there are others that are mature enough to be standardized. And some examples, for example, from the image domain, are classification or object detection, where of course algorithms are still developed and still improved, but the general pipeline or the workflow of how to train an image classifier, that's major enough to be standardized. Or an object detector, that's a well enough known challenge to really be supported by tools, be supported by platforms, and really speed up. Also, other examples from the speech domain. When you have document classification, text classification, or named entity extraction, also those fields are well known well enough to introduce standards and tools and really support people there in development. No ops, low ops, and so on. In a bit of a provocative statement here, with only those 4 tasks that I've mentioned as examples, I guess every company we know could profit already. I've put it probably here such that you don't need to think about examples where I'm wrong, and it's really meant to be a bit provocative, and just once again claim how much you can reach by standardization. So with those standard machine learning tasks and knowing that the platforms could speed up your development process, what are the requirements to such a platform, and how do you really actually speed up development then? Here I've drawn a picture of a classical software development process as of Scrum. You know, you have sprints, you have a backlog, you do a planning. In machine learning, supervised machine learning here, the picture looks a bit different. You have the data acquisition, you need to manage this. You have data annotation, which is a quite laborsome task. You do some experimentation, then you might go back to the data aspect when you recognize you need more data. But in the end, it's not as plannable in the way you used to plan a classical software development, and also the tools are a bit different. Where you manage source code for classical software development, here you not only need to manage a version source code, you also have data and annotations that need to be under version control, etc. So the picture looks a bit different, and from that we derived our very simplified a sketch or architecture sketch of such a platform. We have data management, so the data aspect is one a central piece. You have the very labor intensive annotation is one big part, and then of course the entire learning and model validation on top. This is all on the development side, and then on the model inference and usage side, that's separated a bit, where you can also, in terms of technology that you're using, choose a bit different setting and setup. We have been developing our own platform, and of course we have been asked the question, why are you doing this? There are so many others around. And for the last minutes of the talk, I will give you reasons why we needed to do this, and why this is still also for others a good idea to care about your own machine learning platform. And I will take some of the steps of the machine learning process as examples, and let's start with data acquisition. You have data set or data management as one important task to be covered by a platform, and you might have some specifics in your data. One example that we know of would be Earth observation, where you have satellite data, images you might say, but not classical RGB images, but ones with more channels depending on the instrument. So you don't have data that doesn't fit into the typical asset types. you need to import and convert data from your sources that might be highly individual. You have data generation as an important aspect, where depending on your domain and given all your domain expertise, you might want to augment the real data you have acquired with some generated data, which is a highly customized thing in many use cases. Also, you need your platform to reflect on your workflow that you have developed as a company, and also often contractual constraints laid upon you by your customers or your clients. With data, once you have it in supervised learning, you have annotation is the big part that comes next. I'm skipping preprocessing here. You need efficient tooling for it. Of course, there are many also platforms focusing, or even companies focusing on that. You have AI-assisted labeling, and again, even more important here, user roles and permissions. You might need to outsource labeling to external experts on that topic, or maybe cheaper workforce, Mechanical Turk, for example, just to mention one example. Then at the heart of it, you have the training, of course. Depending on the infrastructure you're working upon, you need to schedule. You might use hyperscalers to get your GPU resources, but when you rely on your own data center, you might need some intelligent scheduling to manage your resources efficiently. You need to persist all your training artifacts, and here I want to mention versioning on all those parts of the picture. And what we also apply, I call it expert moderated training parameterization. And this is where I said I want to lower the entry barrier into machine learning. So we have our experts moderating the process, like suggesting hyperparameters or recommending hyperparameter sets, recommending specific algorithms for certain tasks, such that people with less experience can rely on this and get their first shot on a new task. And only if the result is not satisfying, then the experts can come into play and enhance on that. And of course, you have deployment in the end, where in the ideal case, you in a microservice architecture, you get a fully a self-contained Docker image out of it that has your inference integrated. So what are the takeaways? What do I hope that you take away from this talk? Machine learning platforms are an important tool to increase your efficiency and to lower the entry barrier into AI on the skill level as well on the budget level. And I really hope and I see machine learning platforms as the means to increase the usage of AI overall companies and potential users. Also, do not reinvent the wheel. Rely on standardized pipelines for doing a first shot. You can iterate on it anyways if this is in the end not satisfying. And as a last point, really use machine learning platforms to bring your data science workflows to the same level of professionalism as we are knowing from classical software development already that has been built up over the last decades. And with that takeaways, I want to conclude my talk and once again invite you for any follow-up discussion.
Yes, thanks a lot. Feel free to connect to Mr. Niedermeyer in advance of this presentation. Maybe one very short question to you. A few sentences regarding experiences you have seen within companies building their own AI governance, AI frameworks based on those things, and how does this influence like internal HR setups, internal knowledge setups, like as they build knowledge by developing those things, by setting up those governance and architecture designs.
Yeah. So when you set up such a design, I also see this as a chance to onboard new people into the topic of AI. We've experienced that when building a platform, in addition to the AI core, where you really develop your machine learning pipelines, you have a lot of accompanying software development around. You have the application around it. You have the platform foundations. And this makes many software developers who have not been in touch with the topic before really curious and driving them into the topic already. So I also see it beneficial there to broaden knowledge and broaden awareness of the topic. Same for data governance. Yeah.
Thanks a lot for these very interesting insights. And feel free to connect, as I said, and enjoy connecting and networking on Big Data AI Summit. See you soon. Goodbye. Thanks for having me. Bye. So we are directly jumping to the next session, which is presented by Jörg Meiners. Jörg Meiners is Principal Sales Engineer at Denodo Technologies, and he's talking about simplifying analytics with an enterprise data fabric. The stage is yours.
Okay, thanks a lot. So yeah, welcome, ladies and gentlemen. Jörg Meiners, my name, from Denodo Technologies. I will share my screen with you. Okay, here we go. So yeah, in the next around about 20 minutes, it will be a pleasure for me to show you, explain you how you can simplify your analytics platform with an enterprise data fabric. So the story is, of course, about doing analytics, doing advanced analytics. And I'm pretty sure many of you will know better what advanced analytics means. So it's not only looking to the past, but also looking to the future, how to use machine learning, artificial intelligence to do a forecast, what will happen or what will happen and how you can influence it, right? So the interesting part of that Gartner slide is that in these scenarios, the value out of these scenarios might be higher, so more value, but it's also more difficult to implement them. And one part of that difficulty is that you might need more data. If you do a forecast, you need more data, more complex data, and maybe even real-time data, because it does not make sense to do a forecast based on data which is 1 week old or so, right? So having the data in place, having access to the data is one complexity. I'm pretty sure you all will know it if you are doing advanced analytics. So now, why is it complex to get data, to get access to data? So looking to your data environment or to data environments that customers usually or companies usually have in these days, it's not only a data warehouse, right? So looking 20 years ago, it was a well-established approach. It was a standard approach to load everything inside a data warehouse. And from that perspective, your analytical platform was easy, right? The data is in the data warehouse and you do the reporting or the analytics on top of it. But meanwhile, in the last 10, 20 years, basically all companies have started to store data for very, very good reasons also in other data sources. For example, they have started to implement data lakes to hold semi-structured data or IoT data for a very good reason. It's in the data lake, right? Or you have data in the cloud, in Snowflake, Salesforce, other cloud services, right? For very good reasons. You have data in files in NoSQL databases. Yeah, many other data sources are possible. And again, for very good reasons from an IT perspective, right? But actually that gives you now some complexity to, let's say, have and get access to data, because data is in different data sources. And that is also reflected by this interesting study or evaluation from IDC, which is not too old. It's basically 2 years old, but has been supported by many customers and many companies. So around about 1,000 companies have been asked, how many data sources do you connect if you build an analytical use case, right? And the answer was, in average, 6. So 6 different data sources. Might be spreadsheets, might be databases, and so on. Of course, yeah, quite often data lakes, NoSQL databases. So that is one interesting aspect, which is just underlining what I said before, different data sources, right? On the other hand, another aspect of this study was also that yeah, users intend, of course, to use different tools to work on that use case. So might be BI tools, might be analytical notebooks, might be Python, R, or Scala. So different languages, different tools. And that builds basically the complexity of your environment, of your analytical platform, right? Different data sources, different users with different end user tools. And yeah, you have a kind of spaghetti architecture in between, because you need to deal with different sites, with different protocols, with different data formats, with different copies, with different authorization methods. So quite complex. And that is actually not what you want to care about. You just want to work with your data. So what is the dilemma, to summarize that? On the one hand, business analysts, data scientists want more and more data. They want the data as soon as possible, immediately. On the other hand, your data environment is not even same complex as before. It's even more complex. So two trends that are kind of working against each other, right? So what is or what are the analysts recommending for that, to make the life easier here? They are talking about an enterprise data fabric. There are different definitions from Forrester, from Gartner, from IDC, and so on, from TDW. But I'm referring to the Forrester definition here because it's quite easy to understand. An enterprise data fabric is, so to speak, a technology, an IT component, so to speak, that delivers the data out of the IT, out of these different data systems, in a very intelligent, in a secure, in a self-service manner to the business, to the end users who want to consume the data. However, those enterprise data fabric it is doing, it is these definitions do not talk about do it this way, do it that way. They are just feature-based. So in the evaluation of Forrester, for example, you see on the right side that there are different providers for these data fabrics in the leaders segment, such as SAP, Oracle, and as you have heard, I'm from Denodo. We are this red button here, so one of the leading companies who provides data fabrics. So what is special about our data fabric? And I will give you show you our data fabric just as an example. So what is specific to our data fabric? We are basically the one and only company in this leader segment who is providing a virtual enterprise data fabric. Virtual means we are not really copying data. We are not really using ETL or replication methods to build copies. What we do is we provide a virtual access directly to the data. So why are we doing that? Because, well, the idea of virtualization, and that is not really specific to us, but a general idea of virtualization is to provide more agility, right? So think of virtual machines, server virtualization. It's not a requirement anymore to move boxes around, to plug cables and so on. It's just rule-based. You ramp up a new virtual server by software, by a rule, by pressing a a bottom and the new virtual machine is available. And the same idea is with data virtualization, with a virtual data fabric. So how does it work? In just a few words, we have our Denodo virtual data fabric. Denodo is the Denodo platform in between the data sources on the bottom and the consumers, the end users on the top. What Denodo actually does, it connects to data. We are not copying data, we are not removing data, we are not replicating data, we are just connecting to data in place. Might it be an SAP system, might it be in Hadoop system, Parquet files, an Impala database, classical databases files, we connect to data more or less out of the box. Once we are connected, we are speaking one language on top of this external data, that is SQL language. So you can imagine of this enterprise data fabric as a database. That is actually what we are, technically wise, that has its data not internally, but holds its data really in its original place in the data sources. So based on that, you can now rule-based combine data, transform data. You can build joins between SAP data coming from an SAP and an Oracle database or an Impala database or SparkQL data sources. We can combine and transform rule-based any kind of data, and in that way we build a kind of canonical data model that finally the end users can easily connect in Denodo. So they will just work on this provided data model from Denodo just as it would be physical data, right? And of course, and that is the most important thing, Denodo is a query engine. That is, so to speak, our excellence. We are executing the queries on federated, on heterogeneous data, and we do it with good performance, and that is our agenda, to work even on big data landscapes. By the way, we have also a data catalog integrated, central point for doing security, role-based security, column-level security, monitoring, auditing, and by the way, we can also cache data. So this is really data materialization. So we can cache data, and in that case, end users are not really working on the data sources, but on cached data. So let me give you an example how this works. A customer example, this is Prologis. Prologis is one of the leading companies building those large data warehouses, these large warehouses, especially for the logistic industry. They are working globally. And of course, their challenge is always cost. So if they do a project building a new warehouse, they want to do it with an optimized cost. So now they want to do some analytics while building this warehouse, if they are still on track regarding an optimized cost perspective. I mean, costs are derived or are developed or implemented, influenced by many different aspects. So they want to do a forecast. What will be the final cost and how can we optimize it? How can we influence it? So a typical advanced analytic, a typical forecast use case. So what they actually did is they integrated all the data sources they have into Denodo. As I said before, this goes quite easy. They have combined, transformed and combined this data into a canonical data model or unified data model, or let's call it semantical data model. And finally, they have provided this data model for the usage for the data scientists. They, by the way, use Jupyter Notebook and Python to work now on this data model provided by Denodo. So very easy for them. They do not need to care about the heterogeneous data landscape on the bottom. They have a single point of entry and they can just start to work. So by the way, they have been successfully doing it. They have implemented the procedures and the programs, so to speak, to analyze the data in the way they wanted to do that. But now the next question was, well, I do not only have data scientists, I also have, let's say, casual users, business users, operators, controllers, and so on. So people who do not really like to start and parameterize Python code, right? So what are we doing to give them the same insight? So actually the technology is, I want to keep it short, they have moved the Python code down to a Lambda platform in AWS. So however that works, it's important to understand now, as you can see, we have new tables, new views here in Denodo. And if you run SQL statements on top of that new views here, like should coast and coast prediction, they actually run in the background the Python code in the same way as before. So what have you reached? What is the benefit of that? Well, everyone can now speak SQL language again. You do not start Python code, right? And that actually means that casual users, BI users, can now use standard tools like Tableau to work on this data model, to get the same insight than other people. And by the way, Prologis also established a dashboard to present, to visualize key features of that data model. Okay, in summary of that is, in those scenarios, quite often, not only the data scientists are the stakeholders, not only they benefit from this unified access, but also casual users, operational users, which have operational queries. So performance is important. As I said before, we are designed to deliver performance in big data environments. You would wonder how we do that, because we are not working on a single data silo. We are working on federated queries. So we provide or execute federated queries on different data sources. And that is, of course, more challenging. But again, that is our excellence. That is why we are in the market. That is what we do. We have a query optimizer, to say it in very short words, a query optimizer which is designed to optimize the access down to the different source systems to optimize performance. Anyway, as always, if you work with very big data, it might well be that you must, so to speak, materialize transformed data, because joining them, aggregating them every time from scratch might be still too slow. And that is why we can also do data caching, or I would prefer the word data materialization. So in this red quarter here, what you can see is a typical data model. So you have some base views, you are joining them, you build unions, joins, and so on. You are joining them again to more operational views. And what we actually can do is we can materialize the data on each level of that data model. So that is one way to materialize data, to cache data. The other is called summaries. I don't want to go into details here. You might know it from the from other vendors, from few vendors who call it aggregate awareness. So basically, that means you can build any kind of aggregations and store it in any of your databases, and our optimizer is aware of this pre-aggregated data and will use that pre-aggregation instead of doing the aggregation from scratch if it is performance-wise sensible. Now, let me please quickly finalize the benefits here from 3 different user perspectives. One user perspective is, of course, the end user, the people who want to work with data, the data scientists, the analysts, the BI users. So what is their, let's say, advantage? What is their benefit? You can simply describe that as a kind of data self-service. That is basically what they experience. They have now a single point of access where they find all their data. It's presented to them in a predefined semantical data model. We provide alongside with this data model an integrated data catalog. So end users can find their data, can understand their data, they understand the data lineage and so on, and they can use a tool of their choice to work on that data model. Might it be tools connecting via ODBC, JDBC, using SQL, REST APIs, GraphQL, different protocols, different APIs, tool of the choice. The other advantage is from the perspective of people who take care of data governance. So what they will find is a single point of control where they can apply their governance rules. So combinations of data, transformations of data, security rules, policies, masking, filtering, and so on. And of course, auditing. The last perspective is the perspective of the IT, quite often forgotten. What is the advantage for the IT? Well, they are somehow decoupled from the user access because the users will work on a virtual data model, which is stable. So that actually means that you can in the base here provide even better innovations like migrating from, I don't know, Hive to Impala or from on-premise to cloud. So IT gets more freedom, more independency to do that. Okay, that was my quick run through an enterprise data fabric. Any questions?
Thanks a lot, Mr. Meiners. It was a very interesting presentation, and unfortunately, as we run out of time, I would suggest to all the participants who have questions as a follow-up to you to just connect to Mr. Meiners on LinkedIn or social media or directly via our platform during this second day of the Big Data AI Summit. Thanks a lot for your presentation.
You're welcome. Bye-bye.
Bye-bye.
And good success.
Thank
Bye.
you. So we are jumping to the next session, which is presented by Johannes Sommer. Johannes Sommer is the CEO of Retresco, and he's talking about natural language generation. His presentation has the title, From Data to Insights, How Enterprises Understand the Story Behind Their Data with Natural Language Generation. The floor is yours, Mr. Sommer.
Yeah, thank you very much, and thank you for the opportunity to present here today. My name is Johannes Sommer. I'm, as already said, the Managing Director of Retresco. We are a software development company in the field of natural language processing. We are founded in 2008 and ever since located in Berlin. Today, I will talk about why the use of natural language generation in the context of big data projects is essential for the business success of companies in the future. So let's get started with a little intro by looking at the recent storytelling concerning the big data topic. As you all know, over the last 15 years, there has been a realization that data will change the way we do business. As early as 2010, the Financial Times noted the importance of analyzing real-time data in addition to collecting historical transaction-based data, and how much resources leading companies invest in data management in order to make much better and informed decisions. The image of data as the new oil has taken hold. And today, no one of us here doubts that big data will open up new dimensions in knowledge transfer, in decision-making, and solving all kinds of societal and business problems. The proof is that the business models of today's most valuable companies like Google, Amazon, Facebook, and so on are based on data, and that we now generate 2.5 quintillion bytes of data worldwide every day. So let's be honest, you probably all know this number, but it is a completely intangible figure. Yet 90% of the data that is generated is still unstructured. So it comes from emails, from Twitter and Facebook posts, from chat requests, telephone recordings, or from videos. And in addition to all that, there are countless data generated daily by machines. So we produce a massive amount of data by the software we develop and build up enormous costs. Because all this information is useless unless it is processed in order to make its content useful for business. And again, let's face it, how many successful big data projects do each of you have? And how much effort has already been invested in it? Dr. Varian from Google already put it in a nutshell in 2009 in a very impressive interview. He says that the challenge is to understand, process, visualize, and communicate data in order to create value from it. So the question is, how do we connect the dots? To make the sheer volume of data manageable, companies today are building huge enterprise data warehouses, and they are investing heavily in hardware. To manage all that, we have new roles have emerged in companies, such as data analysts, solution architects, big data, data integration engineers, or data strategists. And above all, it needs business intelligence, which is applied in data processing and data analysis in order to make the masses of data we collect usable. There are countless valuable vendors and BI solutions such as Tableau, Power BI, Qlik, and all the others. But looking at this slide, here too, the question may be asked, who apart from the expert just mentioned uses the BI solutions today? Who apart from a few experts in your companies is able to understand the machine-generated analysis today? In business processes that are critical to companies, there are a large numbers of stakeholders with different requirements, with a wide variety of sometimes contradictory information needs, and with diverse knowledge backgrounds. Do these colleagues really understand what this kinds of visualization of data analysis is all about? To use Dr. Varian's words again, besides all the other points he mentions, communication is needed to extract value from the big data. And communication needs natural language because language is the fundamental layer of human interaction. If we now consider that almost every business model, every business relevant process is based at various points on human interaction and those on language, then the importance of the use of natural language processing becomes apparent. There is much evidence to suggest that a large proportion of interaction based on written or spoken communication between machine and human, human and machine, but also between machine and machine, will in the future become increasingly analyzable and automatable by the use of NLP. There are some impressive indicators that we at Ritresco are not the only one who assign NLP such an enormous impact. Almost all large companies are investing heavily in their own NLP stack, as there are GPT-3 from OpenAI, BERT from Google, Turing NLG from Microsoft, etc. This also can be clearly seen in the number of publications at the most important NLP conference. It's the ACL. In 2020, 165 of the 780 papers published were submitted by teams from Microsoft, Facebook, Google, IBM, Amazon, and Salesforce. These companies invest so heavily in NLP because NLP is the essential driver for any kind of machine-to-human or human-to-machine communication. So back to the question, are there any successful data projects? And the answer is yes, there are already many examples of successful data projects using energy to communicate data insights. And to make it more tangible, let me introduce you to some of them. Based on natural language generation technology, the German Football Association generates automatic football reports for all matches in non-professional football across all leagues in women, men, youth, and senior football. Counting pre and post reports, this comes up to the impressive amount of 124,000 reports every week. So let me take this example to shortly explain to you how energy works. In German football, every referee sends match reports data to the Football Association right after the end of the match. In professional football, data vendors even constantly collect data and transmit data during the match at any time. This data is sent via API to the text engine, which analyzes the data and extracts the relevant information. So, for example, who scored a goal and when, who was substituted, and who was dismissed from the game with a red card. This real actual game-specific data is enriched with historical data, such as that one of the teams is the current champion or has the top scorer in its own ranks. And based on this information, the engine then generates all kinds of different text types, such as match previews, match reports, player portraits, or social media snippets, depending on the use case and the customer. In professional football, if desired, with a high level of narrative design detail based on the detailed data, and in different languages and in real time as soon as the data is available. So knowing that, let's go on and have a short look on other successful examples from different industries where natural language generation is in use. The Commerzbank. The Commerzbank automated the whole process of creating reference letters based on NLG, starting with the automated extraction of relevant employee data from different databases, ending in the automated generation of the fully legal, compliant, and correct reference letter. The Deutsche Telekom uses NLG technology on their voice platforms and make world and open domain knowledge accessible for users of their Hallo Magenta speaker. The real estate platform Immobilien Scout 24 generates exposé texts in real time, just as the user enter the properties and features of their flats and houses. In addition to the user's input data, they also use geodata from third-party databases to comprehensively describe not only the property itself, but also its surroundings. And approximately 75% of this automated text suggestions are accepted as is or only marginally changed by the users. The multinational consumer electronic retail chain MediaMarktSaturn creates descriptions for more than 240,000 of their products across almost all product range types in unique versions on 2 different platforms. And last but not least, NLG is increasingly being integrated into BI solutions in order to create relevant business reports for various stakeholders in real time. So as you can see, there are many existing use cases with an enormous business potential in very different business areas. In the following, I'm going to point out the main 5 values which NLG already makes possible today, and as shown in the previous examples. So again, NLG is able to be the key element in any data to insights process as the optimal interface between people and data. It creates easy to understand reports from complex data, even in multiple languages if required. The technology complements smart data visualization with easy to understand reports to better understand dashboards. With NLG, users can create customized reports with just a few clicks. So NLG enables users with different competencies to find answers to individual questions in their data. With NLG, decisions can be made data-based, informed, and fast. That means that the risk of making wrong decisions due to misinformation can be significantly reduced by using that. And evaluate data, interpret information, and create large volumes of reports at the push of a button. Tasks for which business analysts and also the viewers spend a lot of time can be scaled in a time and cost-saving way. So these are the advantages of NLG already. And so, of course, the question is, what's coming up? So what's the next step in development? And close to this question, there's always the question, will NLG be able to be creative? And probably the answer to this question is yes, it will. Right now, a whole bunch of NLG vendors develop solutions to ease up the access to get NLG into use. Language models such as GPT-3 from OpenAI enable the fully automatic creation of text based on minimum human input. We are ourselves developing solutions in which the software independently makes suggestions for the formulation of texts. So these are very exciting times, and we are still at the beginning of NLP and NLG development. So we as Ritresco strongly believe that in the near future, almost every company in the world will sooner or later use NLG technology to optimize their business processes based on data, consciously or unconsciously. So that's already it. Thank you very much for your attention, and I'm really looking forward to your questions.
Perfect. Thanks a lot for this very interesting insights and what you are doing with your customers. I've maybe one, not a question, like more a vision I would like you to present when it comes to a roadmap. You just said like NLG and LLP is just in the beginning. Big tech is investing a lot. Companies like Retresco are doing a lot too in this field. So what do you see for the next 5, the next 10 years in the field of NLG? What kind of things will we see? What kind of other processes will be automated or automatically be generated by NLG in the future?
Well, I think the question now is, at the moment, it is still, as I try to say, you still need a project to set up a new NLG project. So you have to understand what is the data and what is the purpose to analyze it and what is to tell about it. So you have to prepare and have some experts in place to set a project up. And I think the next evolution is to ease up the usage. So to make it possible that no matter what kind of data you have as input and what kind of insights you need to generate, that you just can, so you can reduce the human need of input at the beginning to get out the right results. So it will be, let's say it easy, it will be kind of more intelligence be able analyzing data, or there will be more content models, text models to ease up the analysis and texting based on data.
Thanks a lot for the insights regarding this vision. We have one question in the chat regarding GDPR. There's someone asking the GDPR National Language Generation. So if you can share your considerations regarding this or your experiences within projects regarding interaction with GDPR.
Well, there is not that issue really. So if you are in a GDPR critical context, then mainly you make a real rule-based approach. So we make a rule-based approach, so you can consider all the rules and teach it to the engine, so you will not be in trouble with GDPR. So you can in advance take this into consideration when set up a project. So this is not a barrier at the moment, as we can reflect it and interact to reflect it. So it's not a some sort of border to set up a project.
Thanks a lot, and thanks a lot also for your presentation. And feel free to connect to Retresco in advance and after this presentation on our platform and also via social media and afterwards. Thanks a lot for your presentation, and enjoy the rest of the Big Data AI Summit.
Thank you very much. Have a good day. Bye-bye.
Thank you. So we are jumping directly to the next session, which is presented by Dr. Sebastian Wieczorek, who is Vice President for AI Technology at SAP, and Dr. Daniel Neuhäuser, who is Head of ERP Core Solutions at Villeroy & Boch. And they present their joint AI business transformation they did, and will present some business process automation use cases they developed together. The stage is yours.
Yeah, thanks, and welcome from my side as well. I'm Sebastian Wieczorek from SAP. With me, Daniel Neuhäuser from Villeroy & Boch, who will present shortly. Let me just share my screen so you can see the slides that I'm looking at. That should be up now. And what we want to do is to give you insights into a concrete case where Villeroy & Boch used existing and let's say innovative assets from SAP to improve business processes on their own IT landscape. What I'm going to do is to give you a bit of introduction to what SAP's portfolio overall looks like, how our approach to AI is. But this will be very brief, and the majority of time I would like to hand over to Daniel so he can give you a lot of, I think, very interesting and meaningful insights into how this kind of transformation works and what are the benefits, what are the potential obstacles, how did Villeroy and Boch tackle the topic of introducing AI. So starting with the market overview, when we talk about AI, I think people have very different understanding of what it can do and where it can be used. And from an SAP perspective, AI has three different facets. One is you have technology and you have AI platforms providing technology for people for data scientists mainly to build up their own algorithms, to train them, to run inference on them. That is one part of it. Then there's of course the usage or the application-specific AI utilization. So taking existing functionality or pre-built functionality, integrating that into applications, and then calling this application AI-enabled applications. And the third one is, of course, you can take other technology platforms and extend them with AI capabilities, like you're extending the application part. Now, SAP is doing all of that. It's a big company. So we're having investments in all three areas, but the prime target from our perspective is application embedded AI. So looking into how can we increase the intelligence of applications that we're providing to our customers, so they don't have to deal with AI implementation and integration projects. However, not every product is facilitating all these tailor-made processes. So that's why you will hear how Villeroy and Boch handled that situation. But in general, the idea is that we at SAP, we have a product strategy with all our front and center products like business networks, industry cloud, business process intelligence, and sustainability management. And underneath you have all the products in this category. Taking that into consideration, there's a data strategy, and there's an AI strategy following this or utilizing this data in order to augment these products so that they can be used off the shelf and can be used without further tailoring by the customers. Obviously, what needs to be done is that you have customer-specific training then of these assets, but the training routines then are part of the onboarding procedures. And on a portfolio level, you see that at the heart of it, we have these business applications that are integrated, as I said, in the portfolio. They're built based on AI functions, so components that we can reuse across our portfolio and running on the platform that we're providing internally for training models, serving models, doing lifecycle management and operation. And within SAP, I'm responsible for this AI. Also have conversational AI, so chatbot capability, digital assistant capabilities, and we have intelligent robotic process automation, which is then a meaningful means to also integrate these AI functions into custom processes. Underneath, of course, we have the business technology platform and other products like SAP Data Intelligence and SAP HANA that also facilitate technology snippets and technology parts that can be used to create AI functions or implement them. And with that introduction, I'm handing over to Daniel to provide us some concrete project overview, and then I will close with some final remarks.
Yes, yes, thank you, and welcome from my side as well. So I would like to go one step back from a solution perspective into more generic approach. What is intelligent decision, or what is intelligent automation, and what's behind? So in the end, if you talk about process automation, in a lot of cases it means automation of decision. And then the question is, what makes a decision intelligent? What is the advantage of intelligent decision, and how could you implement such decisions? So to simplify, we can distinguish two types of decisions: rule-based versus experiential. And I would like to explain shortly what's the difference from my perspective. So a rule-based, it's the classical type. It's ifs and else decisions. So you have a more static setup. Of course, you can design very complex decision trees, but in the end, it's static. You have to design, okay, if something happens, then do that or do something else. That has some advantages. For example, it's traceable, because you can normally understand based on which condition a decision was made. It's mainly transactional for comparable approach. If you talk about enhancement, like custom coding or something. On the other side, you talk about experiential decisions. So that's not static anymore. That's a decision based on pattern recognition, for example. So there, you do not design a clear decision. You design a framework. You train an algorithm to decide on the things you would like to achieve. And then the algorithm classifies pattern, calculates probabilities, and hopefully you get the decision you wanted to have, or it's the right decision. So it's not traceable anymore, not completely traceable, but you can use dynamic, at least partly unstructured process data, like PDF data or something. And at least in the most end-to-end processes I had a look on, there were some decisions which need experiential paths. So the main capability to handle unknown or partly unknown or only partly known situations, in that case, you need some experiential decision processes. And that's what you could see as intelligence in the end. So, and if you go a step in the process, of course, an end-to-end process, you need a combination of both types. It's normally possible, and it's normally as well beneficial. And what we do, we use intelligent RPA as a framework to combine these decision types and to automate processes. And that's the main approach. So we started with RPA, and we developed into a situation that we can switch between rule-based decision, which is workflow design, and experiential decision, which is algorithm driven. So next slide, please. So to go one step, just one example, what is experiential decision based on example document classification. This is a self-trained algorithm. So what we did, we needed to provide a sample set of training data. For each type of document we needed to have classified. So it's for us, it's an invoice, GTC, a delivery note, a dunning letter. So everything, each document we wanted to present to the algorithm would be classified into these types. So the training, we had to pre-classify manually some 100 documents for each type, just to explain, okay, if we present a document like that, that's an invoice. If we present a document like that, that's a delivery note. And the better the quality of the training data is, the better the algorithm works in the end. With this initial training, we had to check is the service working as we expected. So we presented some unknown documents and checked the classification. And now it's important to understand how this classification works. For each document we present to the service, we get an answer with a probability with he detects a document. So on the first line of the table and right above, the result was an invoice because it was 90% probability detected as an invoice. It could be a delivery note, it could be a dunning letter as well, but with very limited probabilities. And that we receive for each document we present. So what we had to define, or what we had to find out, with which threshold a document is correctly classified. So it's very uncommon that you get 100% probability on this on the service, because there are always pattern on each document which could be seen on an invoice and on a delivery note as well. So in our case, for example, we had to define 60% threshold. So with a probability of 60%, it's a very high probability that the invoice is really an invoice as a classification result. So that doesn't mean that we only detect 60% of the invoices, but we are far more, but we do not need 90% probability on that. And that's the whole functionality, and that's the service we embedded into our main use case. So for that, I would like to introduce Carl. Carl is an accountant, and especially Carl is responsible to handle errors in a central invoice email folder. So what does it mean in detail? We have an automatic invoice processing, but some gaps. So in some situations, the current tool does not detect correctly. So especially if we have more than one document type in the email. So if we have emails with delivery notes and commercials or and invoices, it could not be processed automatically. So before that was done manually. So if you please go to the next slide. It was done manually. So the challenge was we have attachments which are not invoices. The manual task, somebody needs to check each attachment, open and check, is it an invoice, is it a Dunning letter, is it a delivery note, and need to combine them manually. For example, if we receive an invoice and delivery note in one email, we normally combine it into one PDF and then send it to processing because we want to archive as well the delivery note. And if you remember the discussion before, the explanation before, that's exactly a field of work for classification algorithm. So it's quite easy because we do not have to extract information on the invoice. We just have to understand, is it an invoice or not? So it's a quite good field of work for them. And that led us to the technical design on the next slide. Where we had three main parts and 3 parts of decisions. So in the first step, we have a rule-based decision, checking the email folder, which is quite easy. Check if an email is there, check if an attachment is there, separate the attachment, and present it to the algorithm, to the service. So then it was the experiential part. We need to classify the document, and we need to receive the classified document. So is it invoice, delivery note, whatever. And then in the third step, we had to implement some decision rules, what to do if we have certain types of documents. But that's again static because it's always the same. If you receive an invoice and a delivery note, it's always the same decision. There's no no complexity behind. And now I would like to present the bot a bit more in detail. Unfortunately, it doesn't make sense to show a video because this bot is working totally unattended without any capturing or so. So it's nothing which could be seen there. But if you could switch to the next slide. So now I just describe the main 4 steps. So as discussed, we receive some error mails in an email folder, and at the moment the bot is looping through the email folder each day. In the second step, we collect all the documents, we check the attachment, and we send to the classification service, and we handle the service response. So classical RPA task. In the next step, it's presented to the service, and we get the answer for each document, which is a classification type. And then we can handle in the 4th step the corresponding result. So that's a decision about the document type. It's a combination and deleting of documents. For example, GTC we normally delete because we don't need it. Invoice and delivery notes we combine, and the Dunning letter we forward to to the correct email address. And then this corrected invoice, because that's our core type, we present again to our current interpretations tool, and then it's working normally. So that's in productive usage since 6 or 8 months. So it works quite stable, and it works very sustainable. And I just prepared some figures how to understand what's the benefit and what's the impact on our process. So we have one, just to compare, we have one smaller bot who is just checking some log files. So it's quite easy. He's opening a log file, checking for the dedicated type of words, and deciding based on that. So classical rule-based, and there we work with around about 98% automation rate. For this bot I described before, based on experiential decisions, we are at the moment on an automation rate of 91%. So only 9% of the cases there's manual rework needed, which is not meaning that the classification is not working. It's as well the major part that we receive, for example, 2 invoices and 2 delivery notes in 1 mail. And that's one of the cases we could not handle automatically at the moment. But just nearly from the beginning, we had around about 90% of the manual work who could be automated. And that one dimension is around about 4,500 documents a year. So to come to the end, were our success criteria for that. It sounds simple, but it's like that. So for us it was beneficial that we had a clear and manageable scope. We didn't have a business critical use case, which makes sense. It's the first step to jump into some AI services. It was decoupled from other processes, so we have no limitations. So if something's going wrong or might go wrong, there's no major dependency to another process. It's decoupled. And we had to focus on the core business case. So what was the business case? Automate the major part of the document classification, and that simplified the discussion as well. In the second step, expectation management, of course, we had every time we involved the end user, we showed the advantages, the disadvantages. We showed in the early stage the classification results, even if they were not perfect in the first step. But it helped that everybody understood how this service is working and what is the potential of this service. And of course, in a third point, proof of concept, the first thing we did before we started is developing the bot, is showing that the classification service is working. And after we could prove that, we started with the rest of the project.
Thanks, Daniel. And let me take over here. I think I just want to wrap it up here. What you have seen is, and I hope you enjoyed it, is a case how one of our customers, Villeroy & Boch, used the AI product portfolio here, the document classification and RPA part, in order to innovate on their own business processes. And I think when we look at the key takeaways, I would like to just highlight that one, I tried to explain briefly how SAP is injecting AI into own business processes, and second, how it's possible that companies are able to take these components to innovate on in their own processes as well. And third, you have seen that Villeroy & Boch is doing exactly that, and is in that way becoming an intelligent enterprise by introducing intelligent features and functions into their own business processes. And with that, we're at the end of the talk. Daniel and I will be very happy to answer your questions if you have any. And here you see some links and also our email addresses in case you want to learn more.
Thanks a lot for the insights. We just hand over one question from the chat to you, whoever wants to answer it. It's about autonomous industrial processes and your views regarding this. And if you if we're not there yet, given this autonomous industrial processes question, what would it demand for further advancements of AI to come to this autonomous industrial processes in this context?
Daniel, do you want to have a go, or should I answer?
No, you could start first, yes.
Okay, I think it's a very broad-ended question, and it of course depends, right? So you have processes that are that can be fully automated, and I think that what Daniel has been showing, I think especially when rule-based approaches have such a significant impact already, I think in those processes you can think about full automation. But then there are processes completely automated, especially when you see that regulations at the moment are coming up that are demanding human oversight at certain points of the interaction. So I think yes, we will see an increase in automation. I think full automation, I mean, yeah, car manufacturers were dreaming about the fully automated plant, and now are going back to introduce more let's say manual working steps in their facilities as well. I think it's going to be in most cases a combination of human oversight or human interaction and processes. But of course, we will see much more automation because the technologies and tools that are present and that are available right now are not used to the extent they could be used. So I think AI, and that's my core belief, is going to lead to a wave of automation, but it's not going to be the result and the goal to fully automate every single process or a single process, but to automate steps in these processes and allow humans to focus on the meaningful steps that you don't want to or you are not able to automate. Daniel,
yeah. So I agree fully, and from my perspective, we try to not to have the target to automate a process 100%, because what we learned that's the last 10-15% in automation are the most time-consuming and the most cost-effective. So it's really that we start with a classical 80-20 rule, bringing some benefits, and then if the process is running and automation is running, maybe there's time or chance for improvement. But fully automation, I guess it's very complex in the end, because each process has some edge cases, some special rules which nobody knows, which are coming up once or twice a year.
Thanks a lot for all those insights. And as you've said in your final conclusions, feel free to the participants of the talk, feel free to connect to the colleagues and to interact on the upcoming time of this Big Data AI Summit and also after the conference. Thanks a lot for your presentation.
Thank you. It was a pleasure. Bye.
See you. So we are directly jumping to the next slot, which is presented by Jörg Niestroy. Jörg Niestroy is the CTO of Omnius, and he's talking in the next minutes about how much data one does need in insurance contexts, and he's talking about claims automation with AI for insurance. The stage is yours, Jörg.
Yeah, hi, thank you. Okay, so I start to share my presentation and hopefully you can see it now. Yeah, first of all, I asked the question, how much data do I need, not only for the insurance industry, it's an overall question, because I got it in a lot of projects in the past, and that were not only in the insurance business. And so therefore, because I got that question that much, I thought maybe it's a good idea to start to think about that and to find a solution. And yeah, today I want to present how to estimate the amount of data a little bit better. But first of all, some insights of me. So I graduated in mathematics and computer science, and I care about software development and data science in the companies where I'm working for. So that at the moment I work for Omnias. I joined them at the beginning of this year, and yeah, a little bit more about Omnias. Omnias is providing AI solutions for claim automations for industry, for the insurance industry. So what we are doing is we want to automate the claims handling more inside of the insurance company. So to create the claim file in the core system, to do things like coverage check or claim indexing, to do a completeness check. And our solutions can be used, for example, in an EFNO solution, so where the insurance customer uses an app to file a claim, and we directly can check the police and check the coverage and do that completeness check based on invoices or on offers from the customer. Yeah, but back again to the question. So how much data do I need? And yeah, as mentioned, this question is coming very often in the beginning of AI projects. And the first and simple answer is it depends. So because it's really up to the use case and the method based on that use case I choose, and also what is the quality of my data. For example, if you have 100 good lines in your data set, the model can be much better than if you have thousands of poor quality lines in your training set with a lot of noise or a lot of gaps. So therefore, it also depends then on the quality. So yeah, first of all, you have to choose your use case, and it's really important to first focus on your use case, and do not start an AI project. Start a project for a use case and discuss if you can use AI methods, and if you can use AI methods, then choose the right one, and then you can check your data if that data fits to the method, to your use case. Yeah, first of all, I want to dive a little bit deeper in the use cases, but this is also just a short overview, because there are a lot of use cases that already can be fulfilled with AI, and also the methods. So I show you some preferred methods based on the use cases, but also there are always some alternatives to that. I want to show you 3 categories of use cases, and then the preferred method you can use to then check the amount of data. The first category for me is forecasting. So a lot of AI models are doing forecasts, for example, revenue forecasting or sales forecasting, churn prediction. So if you use your customer, if you lose your customers, and predict it so that you can contact them upfront, or risk assessment for new customers or new projects, for medical prognosis. These are all, yeah, so you try to predict the future, and you do it often based on structured data, so numbers or other information, Booleans in the data warehouse or in your databases. And the method is regression. Often you choose regression for that, and this is that area of supervised learning methods. And so if you have a use case in that area, you can choose regression, and then you can start to think about the amount of data. Another category is facing to the customer based on semi-structured or unstructured text or voice. So incoming information from your customers via letter mail or email or chatbots, and you want to extract informations or classify documents, for example, to have the next best action guess for that, or to put it in the right process in your company. Yeah, so here you use supervised learning methods like classification, extraction, or natural language processing, and for that you need or you have to structure the data a little bit. You also start maybe with an OCR upfront and then structure the data, because with that absolutely unstructured data in invoices, it's often very hard to extract the information you need. The third category is, for me, is identification and detection based on photos and images. So in the insurance industry, it's often the case that you want to do, for example, damage detection with that. And now it's getting really complex, and you need more and more data to train those models. So, for example, in that picture here, you can see a scratch on a car. But is it a scratch or is it a reflection? Also, for a human, it's not easy to distinguish between both. Therefore, it is harder also for a machine to do it. You have to train it. You have to maybe annotate a lot of data upfront, and then you have to train it based on pictures of several or different situations in life where the picture can be took to document a scratch on the car. The preferred methods here are reinforced learning or unsupervised learning. So more unsupervised learning for image detection, and more reinforced learning if you then also are in that area of autonomous driving or robotics. And methods are, for example, pattern recognition, clustering. So if you choose your use case and select your methods, so coming from that use case, you then can have a first estimation of the data you need, because this picture shows it very good that there is a difference in the methods and the amount of data you need. For traditional machine learning methods like classification or regression, it's very easy. You can start very low and it's getting better, but then you will reach a plateau. And you will recognize that it's not getting better if you provide more and more data. And in the worst case, the performance can also go down with much more data. So therefore, it is limited, the amount of data you need. Deep learning is different to that. So with deep learning, it's more like if you have more data, you will have better performance, and you should provide that much data as you can to have the best performance you can get. So that as a first overview, but I will walk through those three popular areas of AI, and starting with that area of reinforced learning, where you need no data upfront at all. So you can start without any training data sets, because reinforced learning is more about using real-time data from, for example, sensors. And it's used for example, for robots to find a way through an area, or in other areas where you interact with that environment. So you need a simulation environment that provides some real-time data, and these can come from real sensors, or also from simulated sensors or data sources, but it's more about real-time data that you need. So the upfront training data set is really low, and it's all about the environment. If you choose a method from supervised learning, because your use case could be solved with supervised learning, then you need some data upfront, and this data often has to be in a very good condition, or has to have a very good quality. So, for example, if you want to do churn prediction, then you need data from your CRM, and you need maybe some features like the quantity purchased in the past, the amount of touch points in the past from the customers, the age, the gender, whatever. And so you have to select the features upfront, and then you have to maybe clean the data and find lines where not all features are set, and fill the gaps with logic, or remove that lines. And also maybe the data has to be annotated. So if you want to classify incoming documents and distinguish between invoices, applications, or terminations, then you have to annotate them up front to give the machine a hint what is what, and then the machine can learn from that. So yeah, you have to do a lot of data preparation. It is not that much data you need maybe for unsupervised learning, the next area, but it has to be prepared very well. So amount of data, low to medium. Methods in that area of unsupervised learning. So if your use case uses methods from that area, you need more data, or yeah, if you can, the performance will be better and better with more and more data. If your problem is to cluster things without knowing the classes, or if you want to find correlations and rules in your data, or if you want to reduce dimensions, for example, so the output from this can be the input for a classification to reduce some noise or to focus on really important features. Then you choose that unsupervised learning, and yeah, you need a lot of data to do that. And also the quality, the third topic, has to be discussed. Because yeah, also often the question that I get is, we already have big data, but our data scientist complains about having too little data. What happens there? So if you have a data lake with a lot of data in it, but the data is not structured, or the data is not annotated, or there is a lot of data, but it's with a lot of gaps, and you have to fill those gaps, then it doesn't count that you have a data lake or a data warehouse with that much data if it is not prepared to train a model. So, and this is really a lot of effort, and also the daily work of a data scientist is more data cleaning than really prepare methods or train methods or train models. And also the poor quality can be unbalanced data. So you have big data, but in case of fraud detection, for example, you in 100 cases, you have one fraud case. And if you want to have 100 fraud cases to train a model, you need 100 times more data overall because of that unbalanced data in your training set. And also noise is really a problem, because if you have too much noise, too much information that is not important for the model, then you could have an overfitting, so that the model is working very well with the training data, but not in real life. So you have to think about permutations in the epochs of your training, or to use other methods to delete the noise. And also data leakage is a big problem. So if you use your CRM to train a churn prediction, and in that CRM, there's already that flag of a termination of the customers, and you train the model with that, then this is the best feature for the model, but it's not there in real life. So therefore, the model will not work in real life. So if you then choose your use case and select the method and check your data, so how to estimate it? There's several methods to do it. So there's that rule of thumb for regression, for example, that you need 10 times more data as you have features. Or in computer vision, you should have minimum 1,000 images for each class, but also this depends on the complexity of your use case. So if you want to detect a chair on an image, it's easier than to detect different colors of chairs on images, and that is or it's getting more complex if you want to detect chairs with their brand in their color on an image. So then you may need much more images than just to detect a chair on an image. And there's also the method of Vapnik-Chervonkis dimensions, where you calculate the complexity of a model, and the result then gives you the complexity of that model and the dimensions, and you can calculate the amount of data you need based on that. So if you have too less data to start, then often the question is, so can I generate my own data? Yes, it's possible. And it's a misunderstanding. It's not just randomly create data. It's very complex. So you have to have variations of real life data. So, for example, this cat, you can mirror it, you can rotate it, you can randomly place objects on that picture, you can make it darker or lighter or change the colors to simulate the variations that can happen in real life. So you first have to discuss the variations that can happen, and then based on that generate your data. And yeah, it's as mentioned, it's not easy, but it can also be a benefit if you first think about the variations, because then you may have data that you would not get in real life if the training set is too less, because you miss some of those variations in that training set in the real life data. Then if you still have too little data, you should start. So just try different methods. So maybe you also get a good result with the data you already have. Or you can also think about using other methods like deterministic methods instead of stochastic methods. You can try rule engines or other methods. And at the end, there is no bad data. It's always about bad use cases or bad methods that you have to figure out or that you have to deal with, because maybe the data just don't fit you to your use case, and then you have to provide other data. Yeah, that's it.
Jörg, thanks a lot for those very interesting insights, like helping at some point companies to think about how to design their big data architecture, how to design their data landscape to develop AI-based business models in the future. Thanks a lot for this presentation.
You're welcome.
So we are jumping now to a short break, which is lasting for 1 to 2 minutes as we change the moderator. So thanks a lot for for listening to me as a moderator, and especially for sure listening to the panelists and the presentators. So we just conclude with the presentations in 2 minutes. Thanks a lot for having me.
Hello everyone, my name is Alexandra and I will guide you through the afternoon on the Grace Hopper stage. High quality data is the backbone of any data project, not only in the context of big data and AI. Despite the importance of high quality data, many companies still have an overall data health that's unreliable. Our next speaker, Arne Ottens, Senior Solutions Engineer, EMEA Central at Talent Germany, will show you in the next session how enterprises can be enabled to operate with confidence in their data. Arne, we are very excited to hear your presentation.
Thanks for having me. So before we dive into the topic, I want to share with you a few anecdotes. So if you search the internet for machine learning fails, for example, you will find a great variety of different stories about it. But two of them will almost always come up. The first one is from a little company called Microsoft. A few years ago, they tried to implement a chatbot based on artificial intelligence. And it started out as a very caring and lovely chatbot, but overnight it turned into a racist one that also hated the women. And why was that? Because it was fed with bad data, with foul language, from Twitter trolls. The other story I want to share with you is about another small company called IBM, who went on an adventure in order to cure cancer with a special variety of their product called Watson. But unfortunately, they failed as well with their undertaking. And why was that? Because they trained Watson only based on hypothetical data, or in other terms, made up data. So you see, it's not easy to be successful with your machine learning attempts, even if you are one of the major companies out there. But what these failures have in common is that were based on bad, unreliable data that you could not trust. So there's a better example to accomplish a successful endeavors, like again, Microsoft, who were able to predict every single elimination game of the Football World Championship in 2014. But what was the difference? The difference was that they had enough data, trustworthy data, some secret ingredients, of course, and a little bit of magic. But this brings us to the topic of this talk today, how you can detect quality issues in your data using the Talent Trust Score. And that's exactly what we will see in the next few minutes. We will discuss the importance of trusted data, the impact of unreliable data, and how the industry's first data health indicator can help you increase your data health and thus enable you to make better decisions. With this, a very warm welcome from my side. My name is Arne Ottens. I'm a Senior Solutions Engineer at Talent, and as such, I'm responsible for customers with a focus on data management, big data topics, as well as different cloud technologies. My background is originally the software development space and the data engineering space, and I'm thrilled to be here on stage to give you this presentation today. And it is all about trust, as I mentioned in this session already, and trust in your data to be precise, how to measure it, how to improve it, and finally, how to apply it to make better decisions in the end of the day. And what quote could be better for this topic than the one from Salesforce founder Matt Benioff, who says that you should think again if trust is not the most important thing for you and your company. So let that sink in for a second. If the most important thing to you and your company is not trust, you really should look again. And of course, you can only make good decisions based on trust, based on a solid foundation. And it's no wonder that companies nowadays want to be data-driven, because data is really what you need in order to make those decisions. You want to know how successful your marketing campaign was? You need to have data for that. You want to reduce costs in a production environment? You guessed it, you need data for that. However, although most companies, if not all, claim to be data-driven or strive to be data-driven, majority of them also claim that they have an overall data situation that's unreliable and not trustworthy. And this is a big problem. So I recently spoke with a customer, and they were selling a broad variety of different products. But in this Zoom session we had people from different departments, and all had a different understanding of what kind of products they are selling. So no one could tell me with confidence what is their actual product palette. And if you don't have this knowledge, the confidence in your data to make such a statement, how can you actually improve the situation you are in if you, for example, want to do adjustments to your product palette? So keep that in mind. And data chaos, we call it, is really what is standing in the way of companies investing in and getting more return from their data assets. So they want to have trust in their data, but their landscape overall is very complex, and thus it's hindering them to move forward. So in a typical environment we see nowadays, we have data sources 400 plus, so 400 and more different sources to get data from, databases, software as a service applications, and so on and so forth. On top of that, you have a broad variety of different tools to work with this data. So this all adds complexity and overall creates something called shadow IT, which it's estimated to cost you, the entire economy, $1.5 trillion a year. So that's a sheer amount of money, and we should really focus on getting rid of that and to reduce that number. And also, this cost of shadow IT is the one thing, but the other thing that you cannot trust your data is costing you approximately 30% of lost revenue just due to bad data. So overall, you have bad data quality, governance issues because you have so much data sources and toolings. It's costing you 30% of annual revenue, and you have approximately 2/3 of your data sets you have that might be very useful and that might be in very good condition, have very good quality. It's unused because all these hindrances. And finally, it is very difficult due to these obstacles to be successful with your data transformation projects. So it's estimated that almost half of all these data transformation projects fail, while only 10% exceed their expectations. That's certainly something we could change. So as a result of this data chaos, it's very hard for decision makers to make a good decision or to make a decision at all, because they have only limited data, so not all the relevant information is available to them. It might be outdated, so it's not the latest information about a campaign or about your product palette. And it is confusing. It's difficult to understand. There is no documentation about this information. There is no one you can ask because the responsibilities are not clear. Then the information may be accurate. You don't know where it's coming from, whether it is correct, and you should use it at all. And to conclude all this, the data is unreliable. So you don't know whether it's the right to use, whether you are even allowed to use it. And now think about this guy you see here on screen. Maybe he is a CFO, a chief financial officer, who is reviewing some dashboards and reports about the production, about marketing, sales expenses, and he's looking to reduce cost. But where shall he start if the data is so bad and it doesn't give him a solid foundation? Maybe he's a chief revenue officer and wants to make fresh investments into a certain area of the company. Again, if the data is not accurate, where shall he invest? Or maybe it's a marketing officer who wants to check the performance about the last marketing campaigns. Again, all these are typical situations that companies all around the globe face on a daily basis. And based on bad information, bad, unreliable data, they cannot make these decisions with confidence. So I'm asking you, what if your organization could make these decisions with confidence? Maybe you could transform your customer experience. Maybe you could increase operational efficiency. Maybe reduce risk and ensure compliance, which is a big topic in Europe nowadays, or innovate even faster. And this is all what Talent enables you with what we call the trust score. So the Talent trust score measures the health of your business data based on different metrics, and really you can measure all the data you have, any piece of data you have. And think about your daily life. If you want to go to a restaurant, if it's again possible, of course, if you want to go on a vacation, if you want to order takeout, all we do today is we go to an app like TripAdvisor, Uber, Yelp to get information about those services. We want to ensure that what we are ordering next has a high product quality, a high quality of service, and we have all this at our fingertips. And the idea of the Talent Trust Store is to do the very same thing for you based on your data sets. So I talked a lot about this trust score and the concept of trust. Let's dive into a data set we applied this to and see how this actually looks in action. So here we are in a web browser, and we see we are consuming our e-commerce customers data set. And here we already see this trust score and the different dimension it's made out of. So it's not only considering data quality aspects as we see down here, where we have an indication about invalid values, valid values, empty values. And these valid values, they are not only based on, hey, this is a text field, there should be text information in it. It's also considering the context. So if it's identified that most of the information in there is about addresses, it checks the validity against addresses. So is it an address, then it's a valid item, otherwise it's not. And this is the very first dimension over here. The next dimension we have is popularity. So you can give ratings, you can give feedback about your data set. So if you come across a data set that is very popular, you think, hey, this is used across the board, and many users are happy with it, so that might be a very good data set to look into it. And you can even certify it, which will increase the popularity as well. And if a data set is certified, someone puts his name behind it to say, hey, this is trustworthy data. Another aspect we have is the completeness. I already mentioned here in the data quality aspects, we have empty values. The more complete your data set, the higher this completeness score goes. I think that goes without any further information. The next aspect is discoverability. We have further capabilities like giving descriptions about the data sets, like documentation, doing custom attributes, adding tags. So annotate your data set with more information that makes it more transparent to your users. What is this data set about? What shall it be used for? What kind of information will you find in there? This makes a data set discoverable and enables you to have a better understanding after all. And then there's last but not least, the usage indicator. How often is a data set used? How often is it opened? How often is it updated? In what kind of situations is it used? All this feeds into this trust score. And you see here, this data set is not used that much. It has a low popularity and it's not very well documented, which ends up in a trust score of 2.71 out of 5. So this is certainly something we should work on, and this is something you can then do right away. You can start filling these empty values, converting those invalid values into valid ones, and pass it on to a colleague to work on it, so that you not only have a first glance, what is the situation about this data set, but also the possibility to actually increase this trust score, increase the data quality. And yeah, this is, I think the time is almost over now. Like, I think in the last 15 or so minutes, we talked about what the companies nowadays see when it comes to data. They want to be data-driven, but also know that many of their data sets, many of their assets, they cannot really trust, and they need to do something about it. So, and this is why Talent came up with this industry's first data trust score to measure your health Also, in order to get rid of this unbelievable impact of almost 30% of lost revenue. That's just insane. So if you like what you've seen with this trust score in the application, you can go to a website called assessor.trustscore.talent.com and give it a try yourself. So you can throw in your very own data set in order to get these 5 dimensions I just introduced to you. Or if you don't want to throw your trusted data set to us, there's also some examples you can use in order to give it a try and get a sense and the feeling of these trust score calculations. And with that, it was my pleasure, and we can jump to the Q&A.
Thank you very much for introducing the Talent Trust Score to us. So we still have a few minutes for some questions. So what would you say are the main reasons for poor data quality?
Anywhere where human beings are involved, these processes are error prone. Like a hotel chain that was charged with a significant GDPR fine. They tried to improve the processes and speed up the check-in process of their guests. And rather than having different fields for different pieces of information, they just wrote everything in one line. And that was then put into the address field in a database. And when they started to write mails, like physical mails to their clients, all kind of sensitive information was printed on the envelope. So it's everywhere where the human being is involved, you will find errors, and that's just who we are.
Yeah, that's true. And do you think there are certain industries that are more prone to poor data quality than others?
Well, nobody is really protected from poor data quality. And there are certainly industries where it's a more significant risk. Like the banking industry, if you have bad data in there, then you put your business at risk. This hospitality example, but I'm pretty sure all the other industries out there face similar situations, maybe not with a significant impact like that.
Perfect. Thank you very much, Arne, for being here today. And now we are continuing with the program. And it's my pleasure to announce our next guest, who is the Chief Expert AI and Program Manager House of AI at Deutsche Bahn, Dr. Thomas Thiele. Thomas will give us an insight into the roadmap of Deutsche Bahn as an asset-heavy company and the reinterpretation of corporate governance in order to foster the enterprise-wide integration of AI. Thank you for being here today, and we are looking forward to your presentation.
Yes, so thank you very much for the kind introduction. I hope you're able to see my screen right now.
Yes, we can see it.
Yes, perfect. So a short introduction into my topic. The idea was to give you a glimpse at how our current AI topics are developing from strategy towards the company-wide integration, and especially within a very short time frame. So we started with this topic in 2019, and this was the first time I gave a presentation here also at the Bitcoin and AI Summit in 2019. So time for an update right now. And let's start with a chart that I already brought with me in 2019. So the idea why AI at Deutsche Bahn. So what's the idea behind the integration of this technology into a mobility and logistics service provider? And you already mentioned in the introduction the asset-heavy company. Yes, the Deutsche Bahn relies on their assets. And if there's an increasing demand on mobility and logistics, which we emphasized in the pre-COVID-19 area, and we also hope that this will move on further after the vaccinations have been done. So we thought of more capacity on the infrastructure, more people that are traveling, so that an asset-heavy company reacts on that with the extension of their assets, right? So Deutsche Bahn started with their infrastructure extension, and we build up new capacities, which means buying new trains and of course optimize their processes. And the first argument for AI comes in here. So what if we can make better use of our existing assets, if we are able to leverage more capacity out of our trains, be better in maintenance part and so on. And with this, we started in 2019. And what I would like to show you is our current status, because we thought of, well, if we integrate such a technology like artificial intelligence into our company, we have to make it tangible for some sort of asset-heavy company like Deutsche Bahn is. And we started to develop different use cases and projects for that. And what you can see here is a current overview on our current topics, which are mainly centralized on what we call train production. So every process that makes our train running, especially focusing on train operations. So what if a train leaves our depot and comes into maintenance afterwards? So the time when passengers and goods are traveling, and the next step, maintenance, when trains are being prepared for their next rides. So we developed a program out of 13 projects that are in different stages, maturity grades of realization. You see that on that target chart on the left side of this slide here, which means the closer the dots get to the center of the target, the more are in the usable productive state. So we started with the optimization of train dispatching and developed that further to some sort of digital twin for train operations. But we also, let's give an example, in digital train maintenance, we are also focusing on flexible camera diagnosis, implementing, for example, different AI techniques to give us a glimpse on what is currently damaged on our trains. And so the red dots I mentioned before are the ones that I would like to highlight in the upcoming minutes. And this will be also part of what I call AI governance, because we have very large topics which we are developing over all the company, over all different business units. And the idea is how to steer that project, how to come in with some sort of management system. And this leads to some sort of reinterpretation of AI governance at that point. And that leads me to the next aspect here. So the AI governance as a management system, in order to foster integration by a combined governance and project approach. So on the one hand, we are a corporate-wide governance center. On the other hand, we are doing different projects and realizing them from first feasibility studies to products in an iterative manner. And this is where AI governance and the reinterpretation comes in handy in order to serve as a management system and give us some sort of availability, usability, integrity, and functional safety of AI projects. This is not only a technical issue from my point of view. So we are currently focusing not only on the technological basis, which of course have to serve certain functionalities, but also in order to integrate people and the organization into that change processes AI projects currently leading on. So for example, the different user acceptance, the different parts of the organization processes have to be changed, that are parts of our projects too. It's a combined triangle of people, organization, and technology. And on the other hand, sustainability of the projects is a very strong point here, especially in those times we are currently facing, because all the efforts we spent so far need to be some sort of sustainable integration into the different business areas, and not in a proof of concept or feasibility state. And at the first four words I mentioned on that slide, availability, usability, integrity, and functional safety, are topics that I would like to highlight in the upcoming minutes. So functionality, what does that mean for us in an interpretation of AI governance? We have to evaluate and we have to ensure the evaluation and standardized evaluation and robustness of AI models and of course AI services in heavy metal processes. That is especially leads to proofs and of, for example, on functional reliability and fail safety, especially if we are implementing AI procedures in safety critical environments, for example, in maintenance processes, especially when we move on from classical maintenance towards to predictive maintenance, as an example. The integrity is a very strong point here. The handling of training data in heavy metal processes, for example, what does it mean how to design a training data set for an algorithm and also a testing data set in order to avoid biases in that area, to provide proof of functional safety, to assure the explainability, and also to get the users, the different people, the different stakeholders on board for those topics. And this serves to some vertical scaling in the different business areas. So for example, we start a project with some sort of feasibility study, move on to a prototype, move on to a minimum viable product. And with this elemental basis, we come to some sort of vertical scaling in that project. So basically, the idea of bringing a project from the feasibility to a product. But what if, and especially in such a large company at Deutsche Bahn, we also talk about horizontal scaling. I think usability is a very strong point here, and we tackle that point with cross-staffing of projects. So every time we work on the project, we work differently. We work across different business units. On the one hand, we also do some sort of resource split in the different projects. So for example, we incorporate stakeholders from train operations, from maintenance, together with different AI specialists and data specialists in certain projects, and also across different business units, because we tackle projects that are relevant for overarching areas. And this is especially for the usability part in the domain. And on the other hand, we have a strong focus on the people that are developing the different AI procedures. And this is also some sort of career development here. So we connect the different AI experts in some sort of networks, foster the exchange here. Perhaps some people already have developed certain AI components, or also have the idea on how to solve certain problems, and build up those tech communities in order to interconnect the very few people we have that have a strong competence, especially in that area. And the last point here, availability. The most striking point for me here is our inner source principle, which means that we foster the share of components that have already developed as an internal open source approach, tools, processes, and so on, that are developed in the one area could also be shared with another, and also be integrated in what we call our company-wide AI platform. And this sort of horizontal scaling, I would like to emphasize in the upcoming slides, and especially give a connection to the different projects I mentioned on the last chart. So let's start with our core projects. Perhaps some people that are currently listening have also seen my presentation in 2019, where I presented you a first glimpse on this project here, reinforcement learning in the area of train dispatching. You see here on the left slide what we are currently developed for the commuter trains at the S-Bahn Stuttgart, so the commuter trains in Stuttgart. You see here some sort of tool that the dispatching agents are currently able to use, where you can forward and rewind the different traffic. Also based on a simulation, we connect with our different traffic data, and also there's the reinforcement learning AI based on top that evaluates different anomalies, different situations in the network. For example, you see here a train that has a 14 minutes delay in that movie, and the AI gives the people a sort of recommendation on how to change how to efficiently change the row of trains in order to reduce, for example, delay of trains and ensure a better train operations. And what we have developed is this thing from scratch, in meaning get the data together, build up the features, develop the reinforcement learning models, and develop that sort of front end. And the idea was, well, okay, we developed that for the metropolitan areas or metropole areas, and this is currently in production at the Stuttgart region. But what if we could also transfer that horizontally towards other areas? And this is some idea we are currently focusing. Basically, we took the components here, implemented some sort of inner source principle, brought the people together that work on the domain of dispatching, and thought of, okay, let's scale that around different areas in Germany, for example, different commuter trains, or for example, different regional areas. So the extension on the one hand to different locations, and the extension on the one hand to more large geographical areas in order to leverage a more efficient train dispatching and train operations. One example on the area of train operations that we are currently focusing and currently rolling out. So this is an example, especially for the inner source principle. Let's give you a second example here based on train maintenance. We are currently focusing here especially on visual inspection of trains. So for example, a train goes under a certain camera bridge. A camera bridge takes on different images of that train, and these images are evaluated by some sort of AI. And what we are currently developing based on 4 different projects we are focusing here is the development of some sort of AI platform. We call it as an analytical toolbox here for visual inspection. And I would like to give you a short introduction to that too. For example, you see here a movie that is recorded under a camera bridge at the in Munich, for example, at the depot in Munich. A train comes in, you see here this imagery, and you see afterwards how the detection of on the visual inspection based on AI takes place. You see that here, for example, different components are tracked based on their location and are evaluated if there's an anomaly or not. And the idea is, if we look on horizontal scaling here, we have 4 different projects in different business areas of DB. You see here an example of the ICE fleet, which means long distance trains, but also our colleagues that are operating the regional trains, the colleagues from DB Cargo are working on different areas of that. The idea was, okay, this lays the foundation out for some sort of analytics toolbox. And we made up this analytics toolbox, or I give you some sort of idea for this analytics toolbox here, because it mainly tackles the cameras and the data. So standardize the way on the data flows from the shop floor to the evaluation systems. And of course, the integration of into the different maintenance processes. This includes, on the one hand, the integration in standardized large IT systems for that, and of course, the user front end and UI UX. But the core of that is especially the analytics on AI part. So we saw that different areas of train, the visual inspection, and for example, the visual inspection of regional trains are coming together in sort of, they have components in common that have to be detected. So the idea was set up a standardized analytic pipelines, especially for the training of AI models, and doing some sort also of transfer learning in that area. We are currently working on that and have very fruitful results so far, but also evaluate some sort of standardized evaluation for that, because we are in a safety critical area here, especially if a train comes in and this is some sort of automation. You also have to be sure that this is also some sort of explainable, so this comes in handy too. And we build up a technical infrastructure for that because it combines at this point edge and different cloud infrastructure. So to bring this presentation to some sort of conclusion, I brought to you some examples for horizontal scaling, and I would like to end up with some sort of vision here, where the idea is that on the one hand, we have AI governance, the usability or the making data usable as the front line, that also builds up on different data governance activities here, data governance activities that have a strong point at DB, especially that because of our board has decided that our data now is freely available within our company. We have some sort of a board decision for that. And this leads to the idea that, okay, we have some sort of reversal of evidence, right? So if you want to keep your data, you have to give proof that you are not able to share that data. And this lies an excellent foundation for the usage of data governed by the processes that I mentioned before. And from a use case perspective, you see here some sort of imagery we depicted on for the connection of different projects. For example, if I bring the two examples I mentioned together, the prediction of different damages at train in order with dispatching of trains in order to derive a better customer experience during the journey and to bring a more reliable resilience train system. So thank you so much for your attention so far, and now I'm happy to hear your questions.
Thank you very much, Thomas. I think we have time for one last question. And what do you think are the main obstacles that companies face when they introduce a smart data strategy?
Well, from my opinion, you have to focus on that data strategy in the core processes of your company. So I think we followed the idea that if we want to succeed with that idea, you have to integrate the different, you have to integrate the data strategy within the heart of the company. And this is, I think, a strong reason where some data strategies fail, because they're coming from the outside, tackle different processes that are not so relevant for a company. So my idea would be start in the heart of a company, and this was also the idea here at Deutsche Bahn.
Perfect. Thank you very much. For all other questions, the attendees, of course, can connect with you on Swapcard. Thank you very much for being here today.
Thank you too. Bye-bye.
Bye. So now we are moving on to the dark side of the chatbot. Chatbots are much accepted, and everybody can name the key customer advantages and business benefits of a chatbot. However, there's also another side, which can easily become the dark side of chatbots. If not assessed sufficiently, then complexity and additional workloads are created and result in organizational friction and setup and maintenance costs that can exceed the benefits and cost savings by far. To mitigate such negative effects, our next two speakers identified 5 success factors to be aware of. Welcome, Olaf Erichsen, CEO at Heldenkombinat Technologies, and welcome Alexander Potricus, Global Product Owner Chatbot and Chat at TUI.
Many thanks.
Yeah, thank you very much. So let me share my screen with you. So, hi TUI, is there a hairdryer in my hotel room? This is a very typical question from our customers all around the world. From a customer perspective, this one is a very easy question. And I believe that this is an excellent question to answer via chatbot. But the way you answer the question decides if you take the sunny advantages of a chatbot or if you end up on the dark side of the chatbot. Hi, my name is Alexander Potricus. I'm the Global Product Owner for Chatbot at Chat at TUI. TUI is the world leading tourism group, and we have strong tour operators, leading online portals, over 400 hotels and 27 million customers. And of course, our customers have a lot of questions. My daily goal is to answer these customer questions in a better and faster way via chatbot and chat. In the past, I had different chatbot projects, and one of these projects was with Olaf in 2019.
Yes, and I'm Olaf Erichsen, co-founder and CEO of Heldenkombinat Technologies. We help corporates and startups to better understand the requirements and technical success factors of all kinds of machine learning applications, and also conversational AI and chatbots. And that was why Alex and I worked together already in 2019. So if we talk about the dark side of chatbots, there's a sunny side for sure. And this is what everybody's aiming for, bringing down the costs, the operational costs, and increasing the customer satisfaction and the user experience. And that is already happening a lot. Alex? Businesses will save over 2.5 billion hours in customer service by 2023, according to Uniper research. And according to Statista, 64% of businesses believe in delivering a more customized customer support experience here. And chatbots are projected to save 70 cents on average per customer interaction. And the more, it is good to understand that the more conversational the chatbots are, the more they can help the corporates to save money here, because complex conversations last longer, and hence it's more costly when operated with human operators.
So these are quite impressive numbers. But what is the dark side of the chatbot? Today, it is very easy to start a chatbot project. With a lot of chatbot companies, you can start your chatbot project within 24 hours. This is good and the most important step, just to start. But when a chatbot doesn't answer the right questions, when it has a complex and inefficient experience for the customers, you will need to invest enormous resources to change the existing content and to upload new content. So this will increase your IT and your operational cost. So how to avoid getting on the dark side of the chatbot? Olaf and myself have answered this question, and we believe there are 5 success factors. Let me start with the first one. We all know we have to be multi and omni-channel. The customer decides how he wants to contact us. So the customer can contact us via website, social, or via phone. All of these channels have their own requirements and possibilities regarding UX, and you might need to manage your communications by an additional partner. Fortunately, the core functionality, tone, intent, and information in integration with corporate systems and databases are more or less identical. The so-called build once and deploy everywhere approach that we see with some provider options will save your organization enormous efforts in the long run.
Second, we see different approaches currently in the market. The first is the command style. That means if you want A, press A. Technically not so advanced and also only a very small user benefit. The second is FAQ matching, where the input of the user is taken, classified, and then matched against a predefined answer. Technically a little bit more advanced, but the user benefit is still not very large because the answer there is not personalized yet. The third type of complexity is about conversations, where the system asks the user for specifications to better retrieve information from other systems in the corporation. More and more users expect such conversational styles when interacting with organizations, and they are frustrated if the chatbot is limited to pure command style or FAQ matching. And hence, the ability to retrieve, store, and use information provided by the user to personalize the chatbot's answer and recommendations is one key technical success factor here. And it is good to know that you cannot expect an upward compatibility here. That means if you have chosen a provider and the provider can demonstrate or has demonstrated that they're very good with FAQ matching, you cannot trust that they can move into the conversational space as well.
Content is king. I'm sure you all have great content for your customers. At TUI, we offer over 100,000 hotels all around the world to our customers. And I believe that our content team makes a great job to offer relevant information to each of these hotels. So how can we ensure that we provide this fantastic and already existing content to our customers so that we can answer product-related questions? of course, via API. The information management of the chatbot system should not involve extra work, such as copying or verifying the validity of information. You want to have one single point of truth. Additional databases to serve chatbots with information that already exists somewhere else in the organization should be seen as a red flag.
Most chatbot providers today are startups, and the common ground is that startups are good at scaling. But there are more dimensions here with scaling than just scaling via cloud microservices if you have some peaked demands. If your organization wants to serve different languages, you often hear the sales guy saying from the chatbot provider saying, yes, no problem, our neural networks are language agnostic. That's okay, but that's just the algorithm. Also, the system architecture needs to be structured so that you can use what you have built in one language for the other languages as well in a very efficient way. It's a little bit what Alex described in the first point. Build once, deploy everywhere. And even more importantly, the provider needs to have native language speakers, not only for the setup and testing phase, but also later for maintenance and enhancements to come. We have seen most startups failing to fulfill the client's expectations regarding the service levels, especially when 24/7 availability is key to industries like banking, insurance, or with TUI travel. And when different languages, countries, and even time zones are involved.
So last but not least, every IT system is a state of progress. You will probably start with the expert-driven approach. This means your service agents and your sales managers will tell you what are the relevant questions you should answer via chatbot to your customers. But I want you to set up the right KPIs from the very beginning. You should include data experts into your chatbot team. You need to understand who is asking you questions, where they are asking the question, where on the website they are asking the question, and what are the questions you receive from your customers in detail. So which questions can be answered via chatbot and which can't be answered via chatbot at the moment? Where and when are your customers leaving the chat? What they are doing afterwards? So when the customer calls you after the customer has used your chatbot, this might be an indicator that your chatbot was not successful. Only with the right set of data and a data-driven approach and continuously analyzes enhancements, you will improve the automation level and the success of your chatbot. Now you have seen enough text. Now I want to show you a video of the chatbot Olaf, myself, and the team had built in the past in 2019. You will see how we answered pre-travel questions of our customers. The video is in German, but I will voice over the key actions. So once you have identified your customer, I think it's absolutely okay to follow at the beginning the comment style approach, so that your customer understands what options he has to get a needed answer from your chatbot. And of course, it is important to integrate your chatbot to your customer management system. And I think the most important thing is that you give your customers the chance to ask the question as a free text, because this will only enable you to understand the customer needs. When a chatbot recognizes the question, it should get the information from your product information management system or from a content management system. And when there's a workflow in a process, why don't use the chatbot for the workflow, so that there's no human interaction needed.
Yes, many thanks, Alex. And now at the end, we have put together our lessons learned and 5 success factors to stay or get on the sunny side of the chatbot. The first is build once, deploy everywhere, as Alex pointed out. That means search for a solution that you can use for all your communication channels. The second is ability to handle complex dialogues. And even if you start with a command style or with a FAQ style, FAQ matching, which is totally okay, have in mind that the user and the user benefit comes with real conversations, and that the solution provider can accompany you on your journey towards that. That is the ability to handle complex dialogues. Third, one single point of information. Make sure that the solution works with APIs and that it is able to fetch the latest information from corporate systems and databases when needed. Fourth, the fourth success factor is scalability. And here, do not only think about different usage scenarios when you have seasonal peaks. You should consider scalability also from a geographical perspective in terms of language capability and service level support. And fifth, make sure that you have appropriate metrics and insights so that you are able to continuously analyze and enhance the chatbot solution. Recall what Alex said, that in most cases you start from an expert-driven approach, and then you want to switch to the data-driven approach because you want to adapt to the reality. And for this, you need the right tools to really understand what's happening there. That's our 5 success factors here. Thanks a lot.
Yeah. Thank you so much for your interest and for looking for us on the dark side of the chatbot. Yeah, now we are happy to answer your questions, and we are happy to get in touch with you via LinkedIn.
Thank you very much, Alex and Olaf. We already have
one. Or Swapcard.
Yeah, or on Swapcard, of course. Everyone is welcome to use Swapcard to connect, ask questions. But we have also one question from the audience right now, and it is, which conversational AI platform do you use? Maybe.
So at the moment, we decided to use an external and internal partner for the conversation AI chatbot.
Okay, Olaf, you mentioned the sunny side of the chatbot, but are chatbots susceptible to cybersecurity attacks, and how to guard the chatbot?
Okay, I think cybersecurity or attacks, there are 2 different directions maybe to answer this. The first is, I think in all approaches that you want to follow, you will not allow the chatbot to come up with own answers. So it is customer service, even if you work with humans, or if you work with humans, they have a guideline. And of course, this is what you're doing here as well. So you're, from this perspective, I think you're totally safe. The other thing, other perspective can be interesting when you have cyber attacks on with a lot of data, and you have a platform and you use a platform where you have a subscription model or you pay per use. That's a very tricky one, and you need to have measures and you need to have a frame contract that excludes something like this.
Okay, thank you. Then maybe one last question. Who wants, Alex or Olaf, how do you think will the future of the chatbots look like in maybe 2050?
Alex?
Do you want to start, Olaf?
Yes, 2050. It's very hard to think about that, but I think we will see more, of course, voice. So currently voice is experimental. And in the next 5 years already, we will have a lot of traction there. And I think you will converse with chatbots or voice dialogue systems like with every other human, I would accept. I think so. Yeah.
Oh.
My idea is maybe that at the moment you also, when you want to provide a single point of truth or the single point of information, you need to invest a lot of time to structure the data so that the chatbot is able to answer the questions. Maybe in the future you can reduce the effort to structure the data. It will be more easy to answer more questions to the customer via chatbot.
Perfect. Thank you very much for being here today and for your really interesting talk and presentation.
Thanks a lot.
Thanks, bye.
Now I'm very pleased to introduce you to another female expert. She's product owner Big Data and AI at KfW Bankengruppe. Welcome, Dr. Nora Reich. Over 150,000 emails from customers arrive at KfW's customer service center per year. And Nora will show you how KfW automated the manual process of routing each email to the right service client with the use of machine learning techniques. Nora, thank you for being here today.
Thank you very much. Now we will jump into one of the first real big data and AI use cases at KfW Banking Group, and one of the use cases here at the conference. We will see how we can leverage email routing with neural networks. My name is Nora Reich and I'm responsible for big data and AI at KfW. So why did we start with email routing as one of our first AI projects at KfW Bankengruppe? If you have a look at Gartner's analytics maturity model, you see that email routing is far on the right side. Before you can do automation projects, you first have to do your homework regarding databases, business intelligence, basic analytics, and maybe advanced analytics. So why were we able to do the automation case? Although we have some gaps in the stages before. First of all, it was a very cumbersome, time-consuming task for our colleagues in our customer service center to route the emails. We get over 150,000 mails from our customers and partners per year in our KfW customer service center. And the questions our customers pose are really tricky, and they have to be routed to 60 topical folders so that real experts can answer these mails. And we had a rule-based system in place, but many emails had to be sorted manually. Secondly, it was a data source which was large and accessible. We had these 150,000 mails from the last 12 months and the correct folder from these mails for our data training available. And this is what we took. So we took all mails from the last 12 months, which was a huge pile of mails, and used this as for training our machine learning models. Third, think about it. How many KfW branch offices do you have in your city where you are right now? None, because the KfW does not have own branch offices. We work together with other main banks like Sparkasse or Volksbank. So if you need a KfW coronavirus aid, or you need a startup loan, you go to your main bank and you get the KfW loan. And we only have direct customer access through our website, through email, and the phone. So it's a very important customer touch point, and it is very important for customer satisfaction. So we have a very diverse group of partners and customers. For example, students for our student loans, municipalities for different loans for the infrastructure, entrepreneurs of medium-sized companies, founders of startups who need our loans. We have sustainable energy consultants that help our end clients to refurbish their houses in a sustainable way. And we have our financing partners, of course, and all these questions are answered by our customer service center. So what did we exactly do? I already said that we had a rule-based system in place. What does that mean? For example, if in a mail there was the term Baukindergeld, the mail was routed to the Baukindergeld folder. And our task was to find out whether a machine learning model can do this task better. The machine learning model will give us probabilities for every email to which folder the mail belongs, and can route the mail to the folder with the highest probability. So how did we convince our colleagues that this was a good project to start with? We convinced our colleagues by visualization. First of all, we made transparent that we had a large issue with spam emails. At KfW, we cannot remove spam emails before we see them, so we really have to have a look at them first, but they were everywhere because we had no rules for spam. And in fact, spam was if you sort all the mails, spam was the largest group of mails we received in 1 year. And our colleagues, they sorted about 20,000 spam mails per year. Secondly, mails were not only not sorted by the rules, but also wrongly sorted. And it took some time to put the mails from the wrong folder into the correct folder. And for example, we showed this with these Sankey diagrams, how that the rules were not able to really succeed in sorting the mails, sorting a large part of the mails correctly. And our machine learning outcome was much better. We can also see this in the confusion matrix. Here on the left side, you see the confusion matrix of the former system. You see that the mails are scattered all over, which means that most are not routed to the correct folder. The large blue part in the middle, these are the spam mails that are scattered all over. And in the upper left corner, these blue cases show that these are our mails from our student loans. We get many mails to our student loans, and the rules, they succeeded in saying, okay, this email is some kind of student mail. It's about the student loan or the BAföG, which we also do at the KfW, but it did not succeed in the real topic within the student loan area. And on the right side, you see that our neural network model performs very well and can route almost all the mails correctly. Of course, we tried several models, all kinds of classification models, and this was our final model, which really performed well. What we also did, we developed a demonstrator. We worked together in this project with a consultancy, Commasoft, and we built this demonstrator to have a look at difficult emails that were difficult to sort. And we did this also together with our customer agents of our info center. For example, here, the customer has a question on some type of student loan, and we could paste the text into the demonstrator and click on routing starten. And then below the screen, that's why I put it left and right, we got the answer. What would be the decision of the rule-based system and of the neural network? And the rule-based decision in this case says Weiterleitung Ausweiskopie, which is wrong in this case. And the neural network said with the probability of 95%, this topic is Auftragsprogramme Legitimationsprüfung, which is also correct. and in addition, the demonstrator showed the additional topics which would fit with the lower probabilities. And our colleagues really looked at it and said, oh yeah, this is what we need. We also see here that the neural network performs much better than the rules. So what was the return on invest? The share of correctly routed emails was doubled, comparing the rule-based system and the neural network. So we could reduce the manual sorting time. We could halve the manual sorting time. And this was the first release we put into the info center, and now new releases are following where the model performs even better. It also had a contribution to, yes, happier colleagues. They had more time for direct customer contact. So they are customer agents and really want to focus with their time on the customer. It also means on the customer side, of course, quicker response to emails, less waiting time for phone calls. And this has an effect on the increased customer satisfaction. And what did we learn? So first, the key to really make clear to the management and to our colleagues that there's room for improvement was the visualization. It helped to convince the service colleagues and the management to really make the move to AI model solution. Second, this was one of our first AI projects at KfW Banking Group. So there was a huge gap between our ancient IT systems and an AI module. And so we decided to develop the data science model with Python separately from our IT stacks and deployed it at microservice. Basically, we only invested in a laptop with Python for the first release. And this also contributed to convince that we can make this project with only a low investment, but a large difference for our colleagues. And third, of course, automating manual tasks is something that needs to be planned carefully and can only be successful if you work with your colleagues. So we chose this project carefully and talked to them and really found out that this was one of the annoying tasks for them. So in the data preparation and the model development, we really worked side by side with our customer agents and found different solutions and discussed this with them. So the agents really, in the end, appreciate less sorting time and a more direct customer contact. Yes, and this is how we made our project fly.
So thank you very much. We still have some time for questions. So do you have plans to introduce an AI system that would also help you with answering emails? And are there certain things that can be automated?
This is a really good question. This might be a step in the future, yes, answering emails. What we have already is a chatbot. So of course I couldn't see the whole talk, which was before my presentation, but I know it's about chatbot, and we have a chatbot on our website that answers students' questions already, which helped us to reduce the number of emails which reached us. So easy questions can be answered by the chatbot on the website already. But of course, new topics have arisen. For example, the KfW Corona Aid, which has been developed last year, is not in our model installed yet. And we currently do the retraining so that new topics and the new mails can be routed effectively. Yeah.
Very interesting. We also have a question from the audience. Dominic is asking, did you consider using an external mail classification solution?
No. This time we didn't. We had our colleagues tried a mail classification solution from the IT system provider for our call center solution, so for the whole call center IT systems, and it did not work. And yes, then we directly started with an internal solution this time.
Okay, and what other use cases do you envision for natural language processing in the banking sector?
For me, a big thing is the use of natural languages in other banking processes. For example, also during Corona times, the people, we get many mails from people asking that they cannot repay their loans, and they want to repay later. And these kind of processes, so if somebody, for example, a student cannot pay back the student loan, then the student uploads a certificate that says that he's unemployed, and to automate the whole process from reading the PDF with the unemployment certificate and the decision that the student can pay later, and all these things that happen then, so that we can automate the whole process, and NLP will be one part of it.
Perfect. Thank you very much, Nora, for being here today and for the insights. Now we are continuing with machine learning, improving data harmonization. Big data brings many benefits to the healthcare industry that can also be used in the context of artificial intelligence and machine learning for the further development of medicine. The idea of AI and machine learning for the purpose of data harmonization has not yet spread sufficiently. We want to change this as quick as possible, and we are able to change it. And it's my pleasure to welcome Dr. Christian Stephan, CEO at Kairos, for a presentation on machine learning, improving data harmonization.
Yeah, thank you for the kind introduction. So I substitute today Martin Peuker, who couldn't make it today to give this presentation, but I will tell you something about machine learning and the improving of data, especially for harmonization. So everyone is knowing it today that the new resource is even more the data itself. And this is already known by Google and Facebook and Microsoft and Amazon and all others. And this is already known, and the economists described this on 2017 in a newsletter. But why does it take so long for this to become understood and true in the healthcare sector? Because in the healthcare sector, we have even other necessities to do this, and it's not easy to do it directly or today in an easy way. So the healthcare sector generates an estimate of 2.3 exabyte annually, and the growth is even fast as well as in other sectors. However, the data remains untapped, and it's in some cases unstructured. It's a physician letter or something else. It's described in some cases even more on paper and is not digitized at all today. And therefore, it's not useful for research and development for even better therapies within the healthcare sector. So what we need is data harmonization, or at least we call it as well interoperability. So we need, in some cases, at first, a digitization, but also for structuring these data. So these unstructured physician letters, we have to cover the information who is necessary for the physician to make their decision on therapies or diagnosis. And we have to harmonize these information. So often it's the same mean, but it's called different, or it's used with a different vocabulary. So in some cases, we have already digitized these data stocks, but it's not shared. And so no one can use it. And it's, again, untapped for medical research. And in some cases, it also happens that the data protection barriers has to be overcome. So not directly the data protection itself, but in some cases, it's too hard or it's too hard interpreted. And so in some cases, it's also used to do or not to do something with the data, but it's already possible to do that. So we have today a gap of expectation and reality. So the expectation today is the interoperability. The data stream is going all over the world. Everyone can connect each other, and the data flow is very easy. But mainly it looks different. The reality is that we're drowning in this information, and we have also to structure this information and to make it free accessible, of course, only in a pseudonymized way, not only in the way that we can identify the person, the patient behind that, even more only by pseudonymized data to understand the disease behind that, not the patient behind that. So we have to evaluate our medical data, and we need good co-working structure and semantic interoperability to evaluate these data and to have even a big data to use AI at least to even better come to better therapies and diagnostics. So the harmonization is one of the big things, but also the possibility to use AI, because it's already known that AI will save life, or is in some cases doing this already today. So big data can support the development of successful AI systems who are able to make medical research even faster on pseudonymized data. And we can provide these outcomes as well for the healthcare system. So at least also AI can revolutionize the healthcare sector by gaining new insights to the diseases of our time and future. And no one today will neglect this, because we know not even enough about COVID infections, about the outcome of a distinct patient. Some of the patients take it easier, but some of them has fatal diseases and going to death, and we do not know why. So just to describe, what is AI in the medical sector? So of course it's coming from the informatics, and what we try to do is to automate some intelligent behavior and machine learning, and that's the very important part, that we try to simulate more or less a human decision structure to represent intelligent predictability. So the ability of an AI system is to deal as well with the uncertainty, not only with a rule and a strict pathway, even more with the unexpected or a probabilistic information. So, however, the ability to learn is the main requirement of an AI system. So, but let me give you a short overview. So in some cases, there's a misinterpretation of AI. So this is neither learning or nor foreseeing. So you see, we have different cool dioxide measurements within our air, and we can see there is an up and down, and we thought we have understood it, but it's not foreseen that on 1950 it goes up so straight. And this is not AI. This is not able to foresee. And it's also not AI if you have any kind of correlation. You see data, it goes up or goes down and has a rule more or less behind that. That's again not AI. What AI is the learning. So everyone is knowing AlphaGo. So it's a game, and they have several algorithms already in place. And what they do is, okay, we're starting again from scratch. We use our first algorithm, AlphaGo, and let learn a new algorithm with no rules, with no restriction, and play against the other ones and learn by this the game. So it's starting, and after 3 days, because they can even play games even faster than ourselves, they have the first algorithm, AlphaGo Lee, reached and would be even better. And after 40 days, they are even better than the AlphaGo algorithm, who struggle the best AlphaGo Go player in the world. And they believe no human will beat this algorithm in Go. So that is learning, and this is AI. And why do we need this? So just let me explain you in a simple way. So we have these pictures, and if someone should tell you who will be the person behind, then you can't do that. But by learning this, an AI can reconstruct the picture and can say, okay, it seems to me that it could be this person. And if you have this picture and see the original one, then you can see it's really, really close. And that's unable for us as a human to do that. It's only possible by using AI solutions. And that's the same also today possible. So some years ago, it maybe is not possible by a huge data amount to do that. So data and speed is the knowledge today. So that's the way we can go on as well for healthcare data. And let me give you a short first example. So the first one is, there was a publication on June 2016 by Bonnie Prescott. It's a Harvard public research, and it describes the accuracy of a pathologist versus AI for detecting breast cancer. So the machine learning is doing this with 92% accuracy. But the human is doing this even better with a 96% of accuracy. So the conclusion could be that the human are better than AI, and so please let the pathology do the job. Is that right? No, that's wrong, because if you combine now these AI solutions with the speed of the AI and the accuracy of the human, then we get an accuracy of 99.5% and an even faster result. So we can use both. So not only the AI will substitute any kind of other human being, it will help or make it easier for them to find solutions and to have even better, maybe later for physicians, even more time to speak with the patient, because the decision is taking not so much time as he's doing by their own. And that's very important. And give me a second example. So sepsis is one of the diseases that's today even more unknown. So we have, of course, today, maybe 9 people who will die in road traffic. Maybe not today, because we have even smaller amount of traffic today. But however, if you look on the rate of sepsis patients who will die each day, then we will have 160 patients who will die today. And even worse, after they has overcome these sepsis, 35% of the patients who will die in the first year after a sepsis is the disease they're gathering on, or have a treatment against sepsis. And we know something about sepsis, but we see that 4 or 5 people will die in a course of sepsis, and we could not say why this happened. But we can even better use AI as a solution to do that. And so what we have done is we collected data from a network of intensive care patients all over Germany. And we use the whole information, not only the disease, not only the ICD coding or something else, we use every parameter we can get from the patient about the oxygen and as well some blood parameters, and use them to treat an eye to distinguish between a patient who will die within the first 30 days or a patient who will not die within the first 30 days. And this is an answer, or a question at least, that a physician could answer, because we can do this with AI within the first 24 hours. We're measuring these parameters, and then we can tell you if the patient will survive the next 30 days. And that's the way we can use, again, the physician to help them to treat the right person. So to focus on them who has a fatal, at least, outcome of this disease, and even better to understand which one will be the good one who will more or less have a smaller or even better outcome of this disease. So you see that AI is today already possible and usable within the healthcare sector. But what we need at least is even better data, even better harmonized data, and even better sharing of data or free accessible data in a pseudonymized way to treat these kind of AI models and to have even better, at least, outcome for patients. And that's very important for the future. So what we need at least is a to-do list. So the lack of an infrastructure in the healthcare institute has to be or must to be overcome and eliminated. So the healthcare data must be recorded digitally directly at the bedside. The current digitized data must be shared, because then only new models and AI algorithms could be produced. And then we have to make these data interoperable, because the automated analysis of data could be only done if it's in the semantic same description, and we have interfaces to get these data out of several systems that are out there. And therefore, we have to increase the fragmentation or decrease the fragmentation of data, at least, because it has to be, this increasing fragmentation has to be stopped. So the excessive data protection must be as well overcome, because in some cases, we can't do these things however we are using it in a pseudonymized way. Of course, we need data protection. Of course, we need data security, but we have to think about the patient and the help we can do together at the day or today. So thank you for your attention, and I'm happy to have even more questions about my presentation.
Thank you very much, Christian. Are there any best practice guidelines that you could recommend to hospitals that are interested in harmonizing data?
Yeah, there's no easy best practice, because it's a long way to do. So what's happened in a hospital or healthcare sector is mainly the problem that we have several data carrying systems. So we have no standardization, we have a fragmentation of these data. And what a hospital or university hospital has to do in the beginning is to have a data integration. So just try to collect the data out from several systems. Don't substitute these systems, but don't let it increase even more systems, but bring it to one database, bring it into one, we call it data lake for using these data, and then share these data to not only physicians, but even more to researcher on informatics and as well maybe a statistics side.
Thank you. We also have a question from the audience. Oliver is asking, what happens to the false positives? Is there any ethical justification for not treating a single person based on an AI decisions?
No. Yes, of course, there are false positives as well. That's the same like a physician is doing. But however, the AI will not substitute the physician. So it's a predictive possibility. It's a support, a predictive support for the physician. And as well, we have seen in this slide before, we also say, why do we do that? This is not a black box we are using for. We try to tell the physician as well, because we are thinking these parameters is running out or getting increased or decreased. We think about that these patients will be one of the problematic patients. And please decide on your expert knowledge about the strategies for therapy and additional diagnostics.
Perfect. We still have time for one last question. So is there any role for the regulator to play in order to advance data harmonization?
Yes, as well, this is a good question again, because this data harmonization is in some cases only done within one hospital, within one university. That makes sense, of course, to do that. But it's even better if you look even more for national or international standards. And we have already some semantics and ontologies already in place that all over the world would be used even better to describe as well diseases, describe parameters of the patient in a generic way. And if you do that, and you could do that on a starting point, then it's fine. But mainly it's not easy to do that, because then in his history you already have of data, you have to reference your data to these international used ontologies. And that's the way we can go on and further. And this takes time. It's not an easy and automated way to do that. So that's very important. And then you need as well researchers with the right knowledge as well in the healthcare sector to find the right reference between your term and the term is used in international ontologies.
Perfect. Thank you very much for being here today, Christian.
Thank you.
Now, last but not least, I am very happy to welcome Robin Röhm, co-founder and CEO of Aferis, who has a diverse academic background in mathematics, medicine, and philosophy, and also has a passion to solve the greatest challenges of our times. This also brings us directly to his topic, data ecosystems. Robin Röhm will discuss recent trends, successes, and challenges of data ecosystems and their orchestration, touching on technologies such as federated machine learning, privacy-enhancing computations, and confidential computing. Robin, thanks for being here.
Yes, thanks a lot. We are 1 minute early. Maybe we wait until sharp, or what do you think?
I think you can slowly start.
Okay. Then I would share the screen and as such can kick it off. So thank you all for being here. I'm really excited to be here on this conference today, and thanks as well for all the insightful discussions with many of you within these last 2 days. So we are very happy that today's topic is so relevant for many of you. And so what I will be talking about today is how data ecosystems will shape the AI landscape of our decade. And so we'll start by looking at what a data ecosystem actually is, how they are changing our world today, but as well how the future will look like. And we will then look at the 3 core technologies that data ecosystems face, and as well how to overcome them. So let's kick it off. Now, artificial intelligence is a booming technology, and AI usage is transforming every aspect of the modern enterprise. And I think everyone knows that AI is only meaningful if you have enough data. So in this graph here, you see 4 different machine learning algorithms. So that means algorithms with different architectures and inner workings, and all of them are trained on the same natural language processing task. Now, on the horizontal axis, you see the size of the data set. And on the y-axis is the accuracy of the machine learning algorithm. And each of the line represents a different machine learning algorithm. So what we see in this graph is that it basically doesn't matter which algorithm you choose, as long as the data is large enough. And we call this effect the unreasonable effectiveness of data. And it says that size of the data matters far more than the algorithm itself. And that explains why the success of AI applications directly depends on access to the right data. Now, such relevant data for training machine learning models is typically distributed across many different parties. And data sharing between parties or centralizing it is often impossible or harmful for the business. So that means that data scientists today are usually limited to their own proprietary data sets. Now, the reason why companies cannot share their data is because they need to protect the IP of it, but not just the IP of the data, but as well the AI model can be valuable IP. And so whenever you are dealing as well with personal data, the minefield of data protection regulation can be a total barrier for sharing data. And by that, I mean not just giving access to it, but as well receiving such data poses obligations on you. So even in cases where sharing such data would be legal, you'd rather not have it, as you're exposed to rights of individual data subjects you may not be able to comply with. And last but not least, the sharing of data is often not possible because companies cannot trust each other, and so losing control over your data poses a huge risk to the business. Now, collaborative data ecosystems are the alternative to solving exactly that challenge. So the graphic here shows a setup where a number of companies connect some of their proprietary data sets to a joint ecosystem. But the data involved is not shared with the other parties. So as a result, they can jointly draw insights from each other's data. So that's, for example, training a machine learning model. But every data owner and model owner keeps the intellectual property of their data and as well algorithmic assets. Now, all of them benefit here from a huge amount of training data. So remember the graph that I showed in the beginning. And so that means that we get more robust models, often easier to interpret, and as well with higher generalizability. And the benefit here is that the data owners stay always under the full control of their data. And a federated architecture means that data is kept local within isolated and confidential environments. And we bring computations to the data. So that's the idea of a decentralized setup. And as well, typically common and governing frameworks define rules for a given ecosystem to make it valuable, but as well auditable for all parties involved. Now, such collaborative data ecosystems are on the rise across industries, and they are already today revolutionizing how we think about data value and as well how we build data products. And so let's take a quick look at a couple of successful examples. Now, a very prominent example within pharma is the public initiative Melody. So in Melody, many of the largest pharma companies in the world provide their most valuable asset for joint model training. And so that's the data about their own molecules. So what happens then is that drug discovery models are jointly trained on the diverse data of multiple pharma companies. And so these trained models then learn about properties of molecules. And as they've seen so much diverse data, they generalize far better to unseen molecules. And so that's exactly what the pharma companies need to accelerate drug discovery. Similarly, in manufacturing, Musketeer is a data ecosystem where, for example, data from robots is jointly used to train models for predictive maintenance or as well product safety. And so here again, data is not shared between the entities, but each party keeps their data confidential, but nevertheless, they learn jointly from their data. And as well, Gaia-X, which most of you probably have heard about. So Gaia-X is the federated data infrastructure for Europe. And they have multiple use cases where data ecosystems are being developed according to the Gaia-X standards. And so examples here range from data ecosystems between hospitals to data ecosystems between cities or as well financial institutes. And so these here are examples for very large and well-known ecosystems. But maybe even more interesting is that there are numerous examples where private companies started collaborating together on a certain use case and started developing a small data ecosystem out of it. And so what we can be sure of is that the relevance and the value of data ecosystems will increase. And so today, already a vast majority of data analytics professionals know that they need to increase the use of external data sources. And that makes sense in a world where the adoption of AI is accelerating and as well the dependence of data therefore increases. On the other hand, enterprises often gather lots of data, and let's face it, they don't always know what to use it for. And so often there are high value use cases outside of the own organization. So why not just use data and generate revenue with it? However, the more data is generated and the more AI applications are built, the more endangered the personal data of all of us basically is. And so as a result, regulatory barriers will become stricter. And yeah, I think we need to find new ways to ethically use personal data for innovation without putting individuals at risk. And so data ecosystems here will be the key to answer exactly that dilemma. As well, if you think about how COVID-19 accelerated both the need and transition towards global data collaboration. So that's one massive shift that we saw, not just in biomedical R&D, but as well in collaboration across countries, across geographies, or as well organizations. And yeah, so by now, I guess you are convinced that data ecosystems are important and as well will become more important over time. So I think it makes sense to look at what the challenges are to accelerate the transition, and as well how companies can become a thought leader in the data ecosystems that will arise in their industries. And so the three key challenges we need to overcome are: one, we need to break down the complexity. So dealing with such new technological and business concepts is not easy. And so breaking things down into smaller steps is crucial. Then second, we need to enable the full range of data science operations. So what we've seen is technologies that solve only very specific problems. And that makes it hard for industries to learn from each other. And only when we enable real data science, a data ecosystem becomes an alternative to centralized data. And that's not an easy claim. And as well with Apheris, we are super proud to be working on that very exciting problem. And then third, and most importantly, we need holistic security and privacy frameworks. And that means through combining the right technologies, but as well through combining them with the right policies. And so I would suggest that we take a look at each of those challenges and then understand how to cope with them. So let's start with one. Breaking down the business complexity sounds easy, but is often a big challenge. So here we highly recommend starting small while having a bold vision in mind. And both is really important here. So we've seen data ecosystems not get off the ground because the first step was so complex. But we have as well seen data ecosystems that don't evolve because they were limited around a small use case. And so the combination here is really key. Then coupled to that, choosing the right partners is crucial. So both the technology partners, but as well choosing the first ecosystem partners. And then last but not least, very important is that first ecosystem participants focus on a sustainable business model. So not just for themselves, but obviously as well for future participants that then join the ecosystem. Now, the second big challenge that needs to be tackled is putting data scientists into a position to use the tools they're used to when they analyze distributed data in a privacy-preserving manner. And the closer we will get to that goal, the greater the advantage of data ecosystems will be. And at some point, centralized data will become obsolete. Now, that's a big technical challenge. But to be honest, the technical innovation in privacy-enhancing technologies has been so high that we can clearly say that the core technologies here are not the bottleneck. But what's key is getting the right tools and metadata to the data scientists such that it becomes smooth to do data science on not directly accessible data. So this workflow that you see in this picture shows how data scientists access meta information about the data within the ecosystem. So that means they get basically an environment with virtual data, sample data, and as well meta information about the data that enables them to build their data science workflow. Now in our platform, we call this the Apheris Integrated Development Environment. And key here is to support the iterative and hypothesis-driven research flow of a data scientist. Now, for enabling data science on distributed data, and so that's not just model fitting, that's actual data science. Now for that, we can expect lots of product innovation over the upcoming years. And as well, certainly, yeah, you should follow us if you want to stay informed about that, because that's exactly one of our unique selling points with the Apheris platform. Then the third challenge we discuss about today is building a holistic privacy and security framework. And the technological side is one key component for that. And so there's been tremendous innovation in various cryptographic and data privacy technologies. So some examples here are secure multi-party computation. So that's a technique where you jointly compute a function without sharing the raw data between the parties. So these are cryptographic protocols that enable that. Then differential privacy. So differential privacy is, first of all, a very intuitive definition for privacy. And methodologically, we add noise, so statistical noise, to the computation output to ensure that it cannot be tied back to any individual's data in a data set. Then third, privacy-preserving record linkage allows you to link records of so-called vertically distributed data. So that's data where multiple parties have an overlap in their samples, but they capture a different feature space. So I'll give you an example. For example, a genetic lab and a hospital have data about the same patient, but they capture different type of data, obviously. And so what privacy-preserving record linkage allows you is to link such data while preserving the privacy. And then last but not least, homomorphic encryption is a technology where you can compute in the encrypted space. So that means data does not get decrypted during computation. Now, I could be talking on those technologies for a very long time, but what's important here is that one leverages the right combination of such technologies. So these technologies are very complementary. And again, the key here is to enable a data scientist who's not an expert, or not an expert in privacy technologies, to leverage the right approach without needing to become a privacy expert. And if that's done right, and as well coupled to the product innovation that I described before, we see the rise of a new discipline, which I personally couldn't be more excited about. And that's the discipline privacy-preserving data science. So again, if all of this is interesting for you, follow us and accept some breakthrough product innovation over the upcoming years in that field. Now, nevertheless, technology alone is not enough to establish a system that's reliable and trustworthy. And so a strong foundation for that trust is as well an architectural setup that is built with all relevant regulatory frameworks in mind. So you need to configure the architecture to provide for compliance and as well auditability. Then on top of that, the adoption of data ecosystems will greatly benefit from rising market standards. And so today, frameworks for data ecosystems are often custom made. And yeah, we as Zephyrus, we think that this should not be the case. And that's why we partner as well with Gaia-X, because we believe that common rules are critical, and we strongly support such standardized governing policies that provide clearance for everyone, and as well will allow us to learn across industry use cases. Nevertheless, multiple parties with multiple backgrounds have multiple requirements, and all of them need to be addressed to, just make things work. And so on top of our setup and the policies, we see customizable legal frameworks for specific requirements. And those are key to get everyone aligned. Now, with Zephyrus, we have developed a platform for federated and privacy-preserving data science to enable our customers to overcome exactly those business challenges, but as well technological challenges that I described before. And so we help our customers and partners to build and orchestrate collaborative data ecosystems across industries. And the platform is built for data scientists on the one hand, but as well for business executives that need to orchestrate a data ecosystem and then need support on the legal, on the contractual or data governance side. And so with that, I would summarize. So I hope I gave everyone a good overview of how data ecosystems will be key in solving the world's biggest AI challenges. So that's basically through access to diverse data of multiple parties. Now, the core technologies to orchestrate data ecosystems exist, and they grow continuously with further adoption. And so we see this adoption across use cases and industries constantly accelerating already. And so our advice to any data-driven company is to start small today, but have a bold vision in mind and prepare yourself for lots of innovation and disruption in this field. And so if any of those topics we discussed today is interesting for you, feel free to reach out to me, and happy to proceed with a conversation. Here's my mail as well. Or as well, hop on our company profile here at the event and register for our new newsletter. And with that, yeah, I would like to thank everyone for joining the session today. So we're super excited to be part of this fantastic community. Thanks a lot for the great discussions and insights. And so if there's time, I'm happy to take any questions. Thank you.
Thank you very much, Robin. I'll take this chance for one last question. On-device machine learning holds the promise of achieving higher levels of privacy for users. Are there certain use cases where you believe on-device machine learning does not make sense?
So I mean, first of all, I do think that on-device machine learning makes sense for some use cases. I think nevertheless, in particular for highly computational tasks, access to compute is critical. And so, for example, for image analysis, I would say, so for example, medical image analysis, I think you need access to compute. And so it makes sense that this is either in a cloud, obviously here in an isolated and confidential environment, or as well on-prem, but with access to compute. And so that's just one example. So for any high resource intensive task, we would nevertheless recommend a distributed setup, but not on-device machine learning. And so what I discussed about today on the most data ecosystems that we see today are not primarily on-device. Some parts of it might be on-device, but a key of the computation happens either on-prem or in the cloud, but decentralized.
Thank you very much, Robin, for closing this stage today and for the interesting presentation. So at the Grace Hopper stage, our program is over. Thank you for being part of the Big Data AI Summit, the first digital one. If you want, you are cordially invited to join the Harry Seldon stage for the last program items. Thank you very much.
Thank you.